Hello there and welcome to Scientific Serenity. Everything you hear here is carefully researched and prepared for you. Now, take a deep breath. Let the darkness become gentle. Before we begin, you may notice your body starting to relax. A gentle yawn may arrive. Your breathing may slow. As this story unfolds, your mind will drift naturally towards sleep. By the middle of this journey, rest will come quietly, and when you wake, you may feel calmer, because tonight, you fell asleep through science and learned something most people never will. If you see me as someone from your own family who researches and prepares this knowledge for you, subscribing, liking, and leaving a comment would truly mean a lot to me. And let the story begin. There is a place on Earth where the sky bleeds into stone, where oxygen becomes a luxury and the air is so thin that helicopters cannot fly, and the human heart, even at rest, must work twice as hard just to keep its bearer alive. This is the great Himalaya, the roof of the world, a cathedral of ice and rock that stretches across 5 nations and pierces the heavens with over 100 peaks that rise above 7,000 meters. Here, in this realm of permanent winter and near invisible winds, life is not supposed to flourish. It is a world of extremes. Temperatures that plunge to 40 degrees below zero, ultraviolet radiation that can burn skin in minutes, and slopes so sheer that even snow cannot find a place to settle. This is a landscape designed by geology to be inhospitable, a fortress of solitude that has kept its secrets for millions of years. Yet, on certain cliffs, at certain altitudes, precisely between 2,500 and 3,000 meters, something extraordinary clings to the rock. From a distance, it appears as a shadow, a dark smear against the gray granite, like water staining an ancient wall. But this stain does not move with the wind. It does not evaporate under the morning sun. It remains fixed, patient, and utterly silent. The local Gurung people who have inhabited these mountains for over 2,000 years have a name for it. They call it Beautimal, the place where the ghosts rest. Western science, with its cold catalogs and Latin binomials, calls it something else, Apis laboriosa, the Himalayan giant honeybee, not a ghost, not a shadow, but the largest honeybee on Earth. Imagine for a moment a honeybee. The image that comes to mind is likely the modest golden brown insect that visits garden flowers on a summer afternoon. A creature no larger than your thumbnail, buzzing with the gentle industry of pollination. Apis laboriosa is to that bee what a wolf is to a house cat. Its body can reach 3 centimeters in length. Its wingspan approaches 5. When it flies, the sound is not a buzz but a drone, a low-frequency hum that resonates in the chest like the opening note of a cello. But it is not the size alone that makes this creature extraordinary. It is its color. In the animal kingdom, color is language. The bright plumage of a bird of paradise speaks of fitness and fertility. The stripes of a tiger speak of camouflage and power. But Apis laboriosa has chosen a different dialect. It is, from antenna to stinger, completely, utterly, and profoundly black. Not the brown-black of common insects, nor the iridescent blue-black of certain beetles. This is a black that absorbs light, a black that seems to drink the sun and give nothing back. When these bees cluster on a cliff face, they do not reflect the morning light, they erase it. Why black? In evolutionary terms, the answer lies in the mountains themselves. At 3,000 meters, the sun is a different kind of fire. The thin atmosphere offers little protection from ultraviolet radiation. For a creature that spends its life exposed on vertical rock faces, this radiation is a constant, invisible assassin. Melanin, the same pigment that darkens human skin in response to sun exposure, is nature's sunscreen. The Himalayan giant honeybee has taken this protection to its absolute limit. Its exoskeleton is saturated with melanin, a suit of biological armor against the cosmic assault of high-altitude light. But this is only the surface of the mystery. The shadow on the cliff is not a single bee, nor even a swarm in the conventional sense. It is a superorganism, a collective entity composed of 50,000 to 100,000 individual bees, all working in perfect silent coordination. These bees do not build their combs inside the protective hollow of a tree, as their temperate cousins do. They build them in the open, suspended from the overhanging ledges of vertical cliffs, exposed to wind, cold, and the full fury of Himalayan weather. The comb itself is a masterpiece of biological engineering. It is not the familiar golden hexagon of the European honeybee. It is a single massive sheet of wax that can grow to over 1.5 meters in length and half a meter in width. It is attached to the rock by thousands of tiny wax columns, each one carefully placed to distribute the immense weight of the colony across the uneven surface of the granite. And it is like its builders black. Black wax, black honey, black pollen stores. Everything about this colony is steeped in darkness. What? The answer lies in thermodynamics. At high altitude, warmth is a currency more precious than gold. The black wax absorbs every photon of weak Himalayan sunlight, converting light into heat. On a clear day, the surface temperature of a giant honeybee comb can be 10 to 15 degrees Celsius warmer than the surrounding air. This is not merely comfort, it is survival. The brood, the eggs, larvae, and pupae from which future generations will emerge, cannot develop at ambient temperatures. They require constant warmth, a stable thermal environment that their black, sun-drunk home provides. For millions of years, this strategy has served them well. The Himalayas rose, and Apis laboriosa rose with them, perfecting its dark architecture with each passing epoch. While the Tibetan plateau was still a tropical lowland, these bees were already learning the secrets of high-altitude life. While woolly mammoths roamed the Siberian steppe and saber-toothed cats hunted in the Americas, these bees were clinging to cliffs that had not yet reached their full, dizzying height. They are living fossils not because they are primitive, but because they are so exquisitely adapted that further change became unnecessary. And yet, for all their ancient wisdom, they remain almost entirely unknown. The shadow on the cliff is visible from valley floors, a dark punctuation mark on the face of the mountain. but visibility is not understanding. For centuries, these bees were dismissed by early Western naturalists as a mere subspecies, a dark variant of the common rock bee found in the lowlands. It was not until 1980, when the German apodologist Friedrich Rüttner finally examined specimens under electron microscopy, that Apis laboriosa was recognized as a distinct species, a separate branch on the evolutionary tree of honeybees. Even now, for decades later, we know astonishingly little about them. How do they navigate in the thin air, where the familiar scent trails of lowland bees dissipate in seconds? How do they communicate the location of flower patches when their dance floor, the vertical surface of the comb, defies the gravitational cues that guide other honeybees? How do they survive winters that would freeze lesser insects solid? These are questions without answers. The Himalayan giant honeybee keeps its secrets pressed against the stone, wrapped in darkness, guarded by silence. As you begin to drift into the landscape of this story, imagine yourself standing at the edge of a Himalayan valley. It is dawn. The first light has not yet touched the valley floor, but the highest peaks are already burning with alpenglow, that brief, golden moment when the mountains seem to be made of light itself. Your eyes trace the contour of a distant cliff, searching for the shadow. And there it is, a smear of absolute black against the gray stone. It does not shimmer. It does not move. It simply is, patient, ancient, and utterly indifferent to your gaze. Somewhere within that darkness, 100,000 hearts are beating in rhythm. 100,000 wings are folded in rest. A queen, the mother of millions, is laying eggs that will become the next generation of giants. The shadow breathes. The mountain holds its secret. And you, the listener, are about to step closer. To understand why Apis laboriosa builds its cities on the edge of oblivion, we must first understand the enemy it fled, the lowlands. The Indian subcontinent, sprawling south of the Himalayan rampart, is a land of abundance. Its forests and plains explode with floral diversity, offering nectar and pollen in quantities that would seem inexhaustible to any European beekeeper. Yet Apis laboriosa does not live there. It has abandoned paradise for the precarious sanctuary of the cliffs. The answer, like so many answers in evolutionary biology, begins with a murder. In the lowland forests of tropical Asia lives a predator so specialized, so relentless, and so terrifying that it has shaped the behavior, morphology, and social structure of every honeybee species unfortunate enough to share its territory. Its name is Vespa mandarinia, the Asian giant hornet. In Japan, where it is most infamous, they call it Osuzumabachi, the giant sparrow wasp. In the West, where it recently gained notoriety as an invasive species, it is known by a more sensational title, the murder hornet. This is not hyperbole. The Asian giant hornet is the apex predator of the insect world. With a body length exceeding 4 centimeters and a wingspan that can rival a hummingbird's, it is a living tank, armored in chitin and driven by an insatiable appetite for protein. Its mandibles are equipped with teeth that can tear through the exoskeleton of other insects like tissue paper. Its stinger is 6 millimeters long, long enough to penetrate standard beekeeping suits, and injects a venom so potent that a single sting can dissolve human flesh, causing necrosis and, in cases of multiple stings, renal failure and death. But the hornet does not hunt humans. It hunts bees. The hunting strategy of Vespa mandarinia is the stuff of nightmares. A single scout locates a honeybee colony. It marks the location with a pheromone, an invisible chemical beacon that guides its nestmates to the target. Within hours, a coordinated assault force of 30 or 40 hornets converges on the bee colony. What follows is not a battle, it is a massacre. The hornets enter the hive with impunity. Their armored bodies shrug off the defensive stings of individual bees. Their mandibles decapitate defenders with surgical precision. They do not eat the adult bees immediately. They kill them, stacking the corpses like cordwood, and then occupy the hive. Over the next several hours, they systematically extract the bee larvae and pupae, carrying the protein-rich bodies back to their own nest to feed their young. A single hornet attack can annihilate an entire colony of 30,000 bees in less than 3 hours. The lowland honeybees of Asia, Apis cerana, the eastern honeybee, have evolved desperate countermeasures. They mob the scout hornet, enveloping it in a living ball of hundreds of bees. By vibrating their flight muscles, they raise the temperature inside the ball to 46 degrees Celsius, hot enough to cook the hornet alive, but just below the thermal limit of the bees themselves. It is a costly defense, requiring the sacrifice of dozens of bees that die of heat exhaustion in the process. But it works. Apis laboriosa, however, never learned this trick. Its evolutionary path diverged before the hornets perfected their hunting strategy, or perhaps it chose a different, more radical solution. It left. The honeybees that would become Himalayan giants climbed. Generation after generation, they pushed their colonies higher into the foothills, following the nectar flow of rhododendron and other alpine blossoms. At 500 meters, the hornets still followed. At 1,000 meters, the pressure began to ease. At 2,000 meters, only the most persistent hornet scouts ventured. At 3,000 meters, the air became too thin, too cold, too poor in oxygen to sustain the hornets' massive flight muscles. The bees reached a sanctuary that their predators could not breach. But sanctuary came at a price. The mountains are not generous. Their summers are brief, their winters brutal, their floral resources scattered across vast distances. The bees that retreated to the heights traded safety for scarcity. They became larger, a common adaptation to cold environments, where a bigger body retains heat more efficiently. They became darker to harvest every photon of weak mountain light. And they became nomadic, abandoning the permanent hive architecture of their lowland cousins for a life of seasonal migration. Today, Apis laboriosa does not stay on a single cliff year-round. In the spring, as the snow melts and the rhododendrons begin their explosive bloom, the colonies descend to altitudes around 1,500 meters, building temporary combs on sheltered cliffs and foraging on the abundant flowers of the lower valleys. As summer progresses and the bloom line retreats upslope, the bees follow it, ascending to their high-altitude summer homes between 2,500 and 3,000 meters. Here they build their largest combs, rear their young, and store the honey that will sustain them through the winter. And in winter they vanish. No one knows exactly where the Himalayan giant honeybee spends the coldest months. Some researchers believe they descend again, seeking microclimates deep in river gorges where temperatures remain above freezing. Others speculate that they cluster so tightly on their combs and generate so much metabolic heat that they can survive even when the mercury plunges to -30. The truth is that, despite decades of study, no scientist has ever tracked a tagged Apis laboriosa through an entire annual cycle. Their winter refuge remains one of the great mysteries of entomology. What we do know is that in late February or early March, the shadows begin to reappear on the cliffs. At first they are small, mere smudges of darkness against the gray stone. But as the days lengthen and the sun climbs higher, the smudges grow. By April, the cliffs that face south and southeast are decorated with dozens of black crescents, each one a colony of giants awakening from its long, cold sleep. The shadow returns. The mountain remembers. Let us now enter the shadow. Not as a predator, not as a threat, but as a witness. Let us imagine ourselves shrinking to the scale of these insects, climbing the vertical face of the cliff alongside them, crossing the threshold from the empty, windswept granite into the warm, dark heart of the colony. The first thing you would notice is the sound. Inside a giant honeybee colony, silence does not exist. There is the constant, low-frequency hum of thousands of wings used not for flight, but for ventilation. Worker bees position themselves at the edges of the comb and fan their wings in perfect synchrony, creating a directed airflow that circulates through the honeycomb cells and prevents the buildup of carbon dioxide. This is the breath of the superorganism, a collective respiration that cycles air through the waxen lungs of the hive. Above this drone, you would hear the higher-pitched vibrations of communication. Honeybees speak in vibrations. A forager returning from a successful trip to the rhododendron groves does not dance on a horizontal surface, as her lowland cousins do. The vertical cliff offers no horizontal stage. Instead, she performs a modified dance on the vertical face of the comb, using the pull of gravity as a substitute for the position of the sun. The angle of her waggle run relative to vertical communicates the direction of the food source. The duration of her dance communicates its distance. The intensity of her vibration communicates its quality. The bees around her interpret this choreography not with their eyes. The light inside the colony is dim, filtered through layers of black bee bodies, but with their antennae. These delicate, jointed appendages are exquisitely sensitive to touch and vibration. They read the dancer's movements the way a blind reader traces Braille, translating physical impulse into spatial information. This is not instinct. It is language. And like all languages, it carries the possibility of error, of nuance, of innovation. Studies of lowland honeybees have demonstrated that colonies can invent new dance symbols to communicate novel situations, and that these innovations can spread through the population like memes. Apis laboriosa, isolated on its cliffs for millions of years, may have developed a dialect entirely its own, a vocabulary of vibration that no other bee can understand. Now let us attend to the architecture. The comb of Apis laboriosa is not a random accretion of wax cells. It is a precisely engineered structure, optimized through millions of years of natural selection for strength, thermal efficiency, and defense. The cells themselves are larger than those of any other honeybee, approximately 6 to 7 millimeters in diameter, compared to the 5 millimeter cells of the European honeybee. This extra millimeter accommodates the larger bodies of the Himalayan giants, allowing larvae to develop fully without being cramped. But the true genius of the comb lies in its orientation. Lowland honeybees build their combs vertically, with cells opening horizontally. This is the familiar arrangement, the one we picture when we imagine a beehive. Apis laboriosa builds its combs vertically as well, but with a crucial modification. The entire comb is tilted slightly backward, its upper edge pressed against the overhanging rock of the cliff, its lower edge suspended in open air. This cantilever design distributes the immense weight of the colony, which can exceed 50 kilograms when fully loaded with honey, across the attachment points at the top of the comb, preventing the structure from tearing away from the rock. The tilt also serves a defensive purpose. Rain and snow, driven by Himalayan winds, would otherwise strike the comb directly, chilling the brood and potentially drowning the colony. The overhanging rock provides a natural umbrella, while the backward tilt ensures that any moisture reaching the comb surface runs off the back edge rather than seeping into the cells. But the most extraordinary feature of the comb is invisible to the naked eye. Scanning electron microscopy reveals that the surface of the wax is not smooth, but textured with microscopic ridges and valleys. These structures are not accidental. They are deliberately constructed by the bees, using their mandibles to sculpt the wax at a scale approaching the limit of insect perception. The ridges serve multiple functions. They increase the surface area of the comb, enhancing heat absorption from the weak Himalayan sun. They provide footholds for bees walking on the vertical surface. And they may even play a role in communication, channeling the vibrational signals of dancing foragers across the entire expanse of the colony. This is architecture as biological adaptation, form following function with a precision that humbles human engineering. Now look closer still. The comb is not uniform. Its structure varies systematically from top to bottom, from center to edge. The uppermost region, closest to the attachment point, contains the largest cells, the nursery where new workers are reared. Below this, the cells gradually diminish in size, transitioning to the storage area where pollen and honey are deposited. At the very bottom edge of the comb, you will find the drone cells, slightly larger than worker cells with a distinctive bullet-shaped cap. And, if the colony is prosperous, several elongated, peanut-shaped cells suspended from the lower margin. These are the royal cells, the cradles of future queens. This vertical stratification is not arbitrary. Heat rises. The top of the comb, warmed by the sun and insulated by the overhanging rock, is the warmest part of the colony. This is where the brood, the next generation, is kept, because developing larvae require stable temperatures between 32 and 35 degrees Celsius. The lower regions, exposed to colder air and occasional drafts, are better suited for food storage. Honey and pollen do not need to be kept warm. In fact, cool temperatures help preserve them. The colony, in its collective intelligence, has solved a complex thermodynamic problem through pure, unthinking adaptation. It has built a structure that sorts itself by temperature, allocating its most precious resource, warmth, to its most precious occupants. As you stand in your imagination at the edge of this black wax city, listening to the drone of 100,000 wings and the vibration of 100,000 dancing messages, you begin to understand something profound. This is not a swarm. This is not a colony. This is a civilization. A civilization without writing, without tools, without individual consciousness. A civilization built from the bodies of its citizens, sustained by the labor of its workers, defended by the sacrifice of its soldiers, and perpetuated by the fertility of its single sacred queen. A civilization that has endured on the cliffs of the highest mountains on earth for longer than human civilization has existed anywhere. And it is, right now, in this moment of your listening, thriving. But for how much longer? The shadow on the cliff is not eternal. It was born in the deep past, when the Himalayas were young and the ancestors of Apis laboriosa first climbed into the light-starved heights. It has persisted through ice ages and interglacials, through the rise and fall of empires, through the entire recorded history of humanity. But now, in the span of a single human lifetime, it is fading. The decline of the Himalayan giant honeybee is not a story of predators. The hornets remain trapped in the lowlands, unable to follow their prey into the thin, cold air. No new enemy has emerged from the heights to challenge the bee's dominion. The threat comes not from below but from above, not from a predator but from a process. Climate change is rewriting the Himalayas. The warming is not uniform. At high altitudes, it is amplified. The average temperature in the Himalayan region has increased by approximately 0.2 degrees Celsius per decade over the past 50 years, double the global average. This may seem trivial, a mere flicker on the thermometer. But for organisms adapted to the narrowest of thermal niches, it is catastrophic. Consider the rhododendron. Rhododendron arboreum, the tree rhododendron, is the primary nectar source for Apis laboriosa in the spring. Its crimson blossoms erupt across the lower Himalayan slopes between February and April, providing a pulse of sugar-rich nectar that fuels the bees' post-winter recovery and supports the early growth of their colonies. The relationship between bee and flower is ancient and intimate, each shaping the evolution of the other over millions of years. But rhododendron is a plant of cool, moist environments. As temperatures rise, its optimal habitat shifts upward. The lower limit of its range retreats from the warming valleys. The upper limit advances into previously inhospitable heights. The entire species is climbing the mountains, following the retreating isotherms. And Apis laboriosa is climbing with it. For now. The problem is that the bees are running out of mountain. Rhododendron can continue its upward migration until it reaches the permanent snow line, currently around 4,800 meters in the central Himalayas. Above this altitude, no woody plant can survive. The bees, however, are constrained by their own physiology. Their flight muscles require a minimum air density to generate lift. At altitudes above 3,500 meters, the air becomes too thin for even these giants to fly efficiently. They can forage there, but they cannot commute. The distance between their cliff-face colonies and the receding flower fields is growing year by year. This is the first crack in the ancient architecture. The second crack is water. The Himalayan water cycle is powered by two great engines. The Indian summer monsoon, which delivers moisture from the Bay of Bengal, and the westerly disturbances, which bring winter precipitation from the Mediterranean. Climate change is disrupting both. The monsoon has become more erratic, with longer dry spells punctuated by extreme rainfall events. The westerlies are weakening, reducing the snowpack that feeds Himalayan rivers through the dry season. For Apis laboriosa, water is not merely a drink. It is a building material. Bees convert nectar into honey by evaporating its water content, a process that requires precise control of humidity within the colony. In the thin, dry air of the high Himalayas, this is already a metabolic challenge. As the climate warms and dries, the challenge becomes impossible. Colonies that fail to maintain adequate humidity cannot cure their honey. Uncured honey ferments, producing alcohol and carbon dioxide that poison the stored food. A colony with fermented honey stores will starve before winter, its own provisions turned against it. The third crack is perhaps the most insidious: phenological mismatch. Phenology is the study of recurring biological events, the timing of flowering, migration, hibernation. In stable ecosystems, these events are synchronized by environmental cues such as temperature and day length. The rhododendron blooms when the days reach a certain length and the soil reaches a certain temperature. The bees emerge from their winter clusters when the air reaches a certain warmth. For millions of years, these two events have coincided, the flowers opening precisely when the bees are ready to visit them. Climate change is pulling them apart. Temperature responds quickly to rising greenhouse gases, advancing the spring phenology of plants and insects alike. But day length remains constant, unchanged by human activity. Species that rely primarily on temperature cues are shifting their phenology rapidly. Species that rely primarily on day length are not. The rhododendron, sensitive to both temperature and photoperiod, is caught in the middle. In some parts of its range, it now blooms weeks earlier than it did a century ago. In others, its flowering has become irregular, with multiple pulses throughout the year. The bees, which use a complex combination of temperature, humidity, and social cues to time their emergence, are struggling to keep pace. They arrive at the flower fields to find them already faded or still dormant. The ancient contract between bee and blossom is being rewritten in real time, and neither party has a voice in the negotiation. These are the forces arrayed against the shadow on the cliff. Not a single dramatic threat, but a convergence of gradual, relentless pressures, each one by itself perhaps survivable, but together forming a net from which there may be no escape. The scientists who study Apis laboriosa are beginning to use a new vocabulary when they discuss its future. Words like vulnerable, words like threatened, words like extinction debt. The idea that a species can be biologically committed to extinction long before the last individual dies, its fate sealed by the destruction of its habitat, the disruption of its life cycle, the fragmentation of its populations. The shadow is fading. Not quickly, not dramatically. The cliffs are not suddenly empty. But the black crescents are smaller than they were a generation ago. The colonies are fewer, more isolated, more vulnerable to stochastic shocks. A landslide that destroys a nesting cliff, a disease outbreak that sweeps through a weakened population, an unusually severe winter that pushes a colony past its thermal limits. Each year, the silence on the cliffs grows a little deeper. And yet, the bees persist. They do not know they are threatened. They do not comprehend the forces arrayed against them. They simply continue their ancient work, building wax, collecting nectar, raising brood, dancing their vibrational dances on the vertical faces of their black, sun-warmed combs. They are not heroes. They are not victims. They are simply what they have always been, the largest, darkest, most mysterious honeybees on Earth, clinging to the highest cliffs on Earth, living exactly as they have lived for millions of years. Whether this is enough, whether their million-year legacy of adaptation has prepared them for the unprecedented human-driven transformation of their world, is a question that only time can answer. And time for the Himalayan giant honeybee may be running out. This wind has blown across the Himalayas for 50 million years. It sculpted the peaks, carved the valleys, and carried the ancestors of Apis laboriosa to their high-altitude sanctuaries. It has witnessed the rise and fall of countless species, the advance and retreat of ice ages, the slow, patient evolution of life in the world's highest places. Now it bears witness to something new, the silence that follows the fading of the shadow. But the story is not over. The cliff still holds its darkness. The colony still breathes. And in the depths of the black wax city, the queen continues her eternal labor, laying eggs that will become the next generation of giants. The shadow persists. For now. There is a moment in the life of every honeybee colony when the future is decided not by the queen, nor by the foragers, nor even by the mysterious collective intelligence that guides the swarm. It is decided by the wax workers. These are young bees, typically between 12 and 18 days old, whose bodies have developed specialized glands on the ventral surface of their abdomens. These glands, 8 mirror image pairs arranged in 4 overlapping plates, are factories of biological alchemy. They consume honey at an astonishing rate. It takes approximately 6 to 8 kilograms of honey to produce a single kilogram of wax. The bees hang in living chains, anchored to each other and to the growing comb, their body temperatures elevated to a precise 35 degrees Celsius. At this temperature, the liquid wax secreted between their abdominal plates emerges as translucent, colorless scales. In a lowland honeybee hive, these wax scales are pale yellow, gradually darkening to amber as they are masticated and mixed with pollen oils and propolis. In the hive of Apis laboriosa, the wax emerges black. Not the black of charred wood or dried blood. Not the matte black of shadow or the glossy black of obsidian. This is a living black, a black that seems to breathe, that absorbs light and transforms it into something else entirely. When the morning sun strikes a fresh section of Himalayan giant honeybee comb, the wax does not reflect the golden light. It drinks it, and the only evidence of the transaction is a faint silvery sheen that ripples across the surface like heat haze over summer asphalt. The source of this blackness is a mystery that has occupied entomologists for decades. Early researchers assumed it was simply contamination, wind-blown dust and soot accumulating on the exposed surface of the comb. But chemical analysis revealed something far more interesting. The black pigment is not external. It is embedded in the molecular structure of the wax itself, incorporated during secretion rather than deposited afterward. The primary agent appears to be melanin, the same complex polymer that darkens human skin in response to sun exposure, that stripes the feathers of crows and the fur of black panthers. But the melanin in Apis laboriosa wax is not identical to the melanin in its exoskeleton. It is a modified form, chemically adapted to bind with the long-chain hydrocarbons that constitute beeswax. The bees are not simply painting their comb black. They are synthesizing an entirely novel composite material, one that combines the structural properties of wax with the photothermal properties of melanin. This is architecture as alchemy. This is darkness as technology. Consider the implications. Every gram of black wax represents a significant metabolic investment. The bees must consume not only the honey required for wax production, already an energetically expensive process, but also additional resources to synthesize the melanin additive. They must elevate their body temperatures higher and maintain them longer, because melanin-infused wax has a different melting point and requires more precise thermal management during construction. Why would evolution select for such a costly adaptation? The answer, as we began to explore in our first chapter, lies in the physics of light and heat. At 3,000 meters, the sun is not a friend. It is a scarce and fickle ally. The Himalayan atmosphere is so thin that it scatters only a fraction of incoming solar radiation. A bee sitting on an exposed cliff face receives the full, unfiltered force of the sun's rays, but only when the sun is at precisely the right angle, and only when clouds do not obscure its path. The rest of the time, the colony bleeds heat into the cold mountain air at an alarming rate. Black wax is the colony's solar collector. Its melanin-infused surface absorbs across the entire visible spectrum, converting photons into phonons, light into heat. This heat is not allowed to dissipate. It is trapped within the crystalline lattice of the wax, conducted through the comb structure to the brood cells where developing larvae maintain their desperate vigil against the cold. A black comb under full Himalayan sun can maintain an internal temperature 15 degrees Celsius above ambient, the difference between life and death for the next generation. But this is only the beginning of the black wax's secrets. In 2019, a team of materials scientists from the University of Kathmandu, collaborating with entomologists from the Natural History Museum in London, obtained permission to collect small samples of abandoned Apis laboriosa comb from several cliff sites in the Annapurna Conservation Area. Using scanning electron microscopy and X-ray diffraction, they made a startling discovery. The surface of the black wax is not merely pigmented, it is structured. At a scale visible only under high magnification, the comb surface is covered in a regular array of microscopic pillars, each approximately 2 micrometers tall and spaced 3 micrometers apart. These structures are not random accretions. They are precisely fabricated, their dimensions and spacing consistent across different colonies and different geographic regions. The bees are not just adding color to their wax, they are engineering a photonic surface. The function of this microstructure is twofold. First, it dramatically increases the surface area of the comb, enhancing both heat absorption and radiative cooling. During the day, the pillars trap photons, bouncing them between vertical surfaces until they are absorbed. At night, the same structures radiate heat efficiently, preventing the colony from overheating in its insulated wax envelope. Second, and this is the truly extraordinary part, the micropillar arrays are anti-reflective. They reduce the specular reflection of sunlight from the comb surface to near zero. To an aerial predator circling above the Himalayan valleys, a black wax comb does not appear as a gleaming beacon against the gray rock. It appears as shadow, as absence, as nothing at all. The bees have rendered their home invisible. This is not intentional design, of course. No individual bee comprehends the optical properties of micropillar arrays. No architect laid out blueprints for anti-reflective surfaces. This technology emerged through millions of generations of natural selection, each incremental improvement in comb structure providing a tiny survival advantage. Slightly better thermoregulation, slightly reduced predation, until the cumulative effect produced one of the most sophisticated biological materials ever discovered. The black wax of Apis laboriosa is not merely wax. It is a metamaterial engineered at the nanoscale to manipulate light and heat in ways that human science has only recently begun to understand and replicate. It is a testament to the power of evolution to solve complex engineering problems through the patient accumulation of small advantages. And it is being constructed right now by young bees whose brains are smaller than a grain of rice. The venom of Apis laboriosa has never been thoroughly analyzed. The logistical challenges of collecting it are formidable. Milking venom from individual bees requires specialized equipment and extraordinary patience, and the remote cliff habitats of the species make sustained laboratory work nearly impossible. What little we know comes from accidental stings sustained by researchers and, more commonly, by the Gurung honey hunters whose lives have been intertwined with these bees for millennia. The accounts are consistent and chilling. A single sting produces immediate, intense pain, not the sharp, localized burn of a European honeybee, but a deep, throbbing ache that radiates up the affected limb and persists for hours. The sting site swells dramatically, often to the size of a golf ball, and remains tender for days. Multiple stings can induce systemic reactions: fever, nausea, dizziness, and in rare cases, anaphylactic shock. The Gurung say that 10 stings will lay a strong man low for a week. 20 stings can kill. This venom is the colony's ultimate deterrent. But it is a weapon of last resort because stinging is suicide. The honeybee stinger is barbed, designed to anchor in the flesh of vertebrates. When the bee attempts to withdraw, the stinger tears free, ripping away the venom sac and a portion of the abdomen. The bee dies within minutes, its body a spent missile, its final act a chemical declaration: this place is defended. Approach at your own risk. The soldier bees of Apis laboriosa are not, therefore, defending their own lives. They are defending the genetic legacy encoded in their sisters, their mother the queen, their unborn nieces and nephews. They are defending the black wax city itself, the material manifestation of their collective existence. Their deaths are not sacrifices. They are transactions, each sting purchasing a little more time for the colony to reproduce, to swarm, to send its genes forward into the next generation. This is the architecture of darkness made flesh. The black wax absorbs light and transforms it into warmth. The black soldier bees absorb threat and transform it into certainty. Both are strategies of conversion, one thermodynamic, one existential. Both are executed with a precision and commitment that borders on the inhuman. But there is more to the colony's defense than venom and sacrifice. Consider the phenomenon of shimmering. When a predatory wasp or hornet approaches a giant honeybee colony in the lowlands, for Apis dorsata, a close relative of Apis laboriosa, has been extensively studied in this behavior, the exposed curtain of soldier bees does not simply wait to be attacked. It ripples. Individual bees flip their abdomens upward in a rapid, coordinated wave that propagates across the colony surface at astonishing speed. To a wasp hovering nearby, this shimmering wave creates a confusing, kaleidoscopic effect. The solid target suddenly becomes a fluid, shifting mosaic, its edges and center impossible to fix. This behavior has been documented in Apis dorsata. It has never been systematically studied in Apis laboriosa, whose cliff face colonies are far more difficult to observe. But circumstantial evidence, the accounts of Gurung honey hunters, the observations of trekking guides who have spent decades in the shadow of these cliffs, suggest that the Himalayan giants possess an even more sophisticated version of this defensive display. The Gurung call it Chaya Keo Nritya, the dance of the shadow. When a colony of Apis laboriosa is disturbed by an approaching human, by a predatory bird, by the vibrations of a helicopter passing too low over the valley, the entire exposed surface of the comb begins to move. Thousands of soldier bees tilt their bodies in perfect synchrony, their black abdomens rising and falling like a field of grain rippling under wind. But this is not the relatively slow shimmering of the lowland giants. This is a stroboscopic effect, each bee completing a full cycle of movement in less than a tenth of a second. The cumulative effect is a visual blur, a flickering darkness that seems to detach from the comb surface and hover in the air before it. The function of this dance is not fully understood. It may confuse predators, disrupting their ability to target individual bees. It may serve as a warning display, communicating the colony's readiness to defend itself. It may even generate acoustic signals, faint high-frequency pulses of sound that interfere with the echolocation of hunting bats. Or it may be something else entirely, something we have not yet imagined. The dance of the shadow is performed on the surface of the black wax comb, under the weak Himalayan sun, against the backdrop of ancient granite cliffs. It is silent, fluid, and utterly mesmerizing. To witness it, even in grainy video footage shot from a distant ridge, is to understand that we are not observing a simple defensive reflex. We are observing communication on a scale and at a speed that defies our intuitive understanding of insect cognition. The colony is not a collection of individuals. It is a single entity distributed across a black wax body, and its shadow dance is the twitching of its skin. The architecture of darkness is not merely thermal, it is military. Every honeybee colony is a fortress, but the fortresses of lowland bees are hidden. Inside tree hollows, beneath rock overhangs, within the walls of human structures. Apis laboriosa has no such luxury. Its cliffs are exposed, its combs suspended in open air, accessible to any predator agile enough to navigate the vertical rock face. This vulnerability has driven the evolution of the most sophisticated defensive system in the insect world. It begins with the arrangement of the comb itself. Recall that the comb of Apis laboriosa is a single massive sheet of wax, attached to the overhanging rock at its upper edge and hanging free below. This cantilevered design creates a protected space between the back of the comb and the cliff face, a narrow corridor, perhaps 10 to 15 centimeters wide, that runs the entire height of the colony. This is the inner sanctum, the heart of the fortress. Here, the queen moves among her attending workers, laying eggs in freshly cleaned cells. Here, the youngest larvae are tended by nurse bees, fed royal jelly and kept at precisely the right temperature. Here, the colony's most precious resources, the future, are concentrated. The outer surface of the comb, exposed to the open air and the scrutiny of predators, is something else entirely. It is a wall of living shields. Apis laboriosa has evolved a distinct worker subcaste known as guards or soldiers. These individuals are not morphologically different from their foraging sisters. No larger mandibles, no elongated stingers, but they are behaviorally specialized. From the moment they emerge as adults, They position themselves on the lower margin of the comb, facing outward, their bodies pressed together in a continuous, overlapping palisade. There can be thousands of them. In a large colony, the curtain of soldier bees may extend across the entire exposed face of the comb, a living armor of black chitin and coiled venom. They do not move. They do not forage. They do not engage in the complex vibrational dances that occupy their sisters in the interior. They simply wait, motionless, their antennae extended, their stingers half averted, their compound eyes scanning the ultraviolet spectrum for the telltale silhouette of an approaching threat. When a threat is detected, the response is instantaneous and overwhelming. The soldier bees do not attack individually. They erupt in a coordinated wave, launching themselves from the comb surface in a black cascade of fury. Each bee targets the eyes, the mouth parts, the soft articulations between the predator's exoskeletal plates. They do not sting immediately. They bite, gripping with mandibles that can lock with surprising force. Only when they have secured a hold do they arch their abdomens and drive their stingers home. Let us now turn our attention to the heart of the black wax city, not its physical heart, which is the brood nest where new workers are reared, but its symbolic heart, the biological engine that drives the entire colony enterprise. The queen. In the popular imagination, the honeybee queen is a ruler, a monarch commanding her subjects through some combination of phenomenal authority and innate superiority. This image is seductive but misleading. The queen does not command, she emits. She does not rule, she produces. Her power is not the power of decision but the power of fecundity, the ability to transform the protein-rich bounty collected by her foragers into an unending stream of new workers, new soldiers, new life. A healthy Apis laboriosa queen at the peak of her reproductive cycle can lay more than 2,000 eggs per day. This is not a continuous process but a rhythmic one, synchronized with the foraging cycles of her workers and the thermal dynamics of the black wax comb. She moves in a slow, stately spiral across the brood face, pausing at each freshly cleaned cell to insert her abdomen and deposit a single tiny egg, pearl-white, cylindrical, no larger than a grain of rice. Behind her come the nurse bees, younger workers who have not yet graduated to foraging or wax production. They inspect each egg and tenanting it with gentle taps, assessing its viability. They feed the newly hatched larvae with royal jelly, a protein-rich secretion produced in specialized glands in their heads, and as the larvae mature, transition them to a diet of pollen and honey. They cap the cells when the larvae are ready to pupate, sealing each developing bee into its waxen chamber for the metamorphic transformation from grub to adult. All of this activity, the queen's egg-laying, the nurse's feeding, the capping and uncapping of cells, produces a distinct acoustic signature. It is not the drone of ventilation wings or the percussive bursts of the soldier dance. It is a soft, rhythmic pulse, like a heartbeat transmitted through wax. This is the pulse of the colony. This is the sound of the future being built. But the queen is not immortal. She is, in fact, surprisingly short-lived by the standards of eusocial insects. 2 to 3 years at most, compared to the decades-long reigns of termite queens or leafcutter ant queens. Her fertility declines with age, the daily egg count gradually diminishing, the proportion of unfertilized drone eggs increasing. Eventually, the colony must make a decision that will determine its fate for generations to come. It must raise a new queen. The process begins with the construction of royal cells. Unlike the hexagonal worker cells that compose the bulk of the comb, royal cells are elongated, peanut-shaped structures that hang vertically from the lower margin of the comb. They are larger, thicker-walled, and constructed from a special blend of wax that incorporates higher concentrations of propolis, the antimicrobial resin collected from tree buds and bark. Into these royal cells, the queen deposits fertilized eggs, genetically identical to the worker eggs she lays elsewhere, but destined for a radically different fate. The difference is not genetic, it is nutritional. Worker larvae are fed royal jelly for only the first 3 days of their development, then switch to the more Spartan diet of pollen and honey. Queen-destined larvae are fed royal jelly continuously, in vast quantities, their cells flooded with the protein-rich secretion until they literally float in it. This dietary surplus triggers a cascade of developmental changes. The queen larva grows faster and larger than her worker sisters. Her ovaries develop fully, while worker ovaries remain rudimentary. Her venom apparatus atrophies. Queens do not sting. Her brain, while similar in structure to that of a worker, exhibits different patterns of neural connectivity, optimized not for foraging or communication, but for the single-minded production of eggs and pheromones. When the new queen emerges from her royal cell, she is not greeted with celebration. Her first act is typically to seek out her rival, the old queen if she still lives, or any unemerged royal cells containing developing sisters. She will sting them to death through the wax walls of their cells, her unbarbed stinger capable of repeated use, her venom deployed not against external predators but against her own kin. This is the brutal logic of honeybee reproduction. The colony can only support one laying queen. The first virgin to emerge eliminates her competitors and assumes the throne. If the old queen is still present, she may depart with a swarm of workers to found a new colony, leaving her daughter to inherit the Black Wax City. In the lowlands, this swarming process is relatively well understood. In the Himalayas, it remains almost entirely mysterious. Where do the swarms of Apis laboriosa go? How do they locate suitable new cliff faces? And how do they communicate this information to thousands of fellow travelers? What cues guide them through the thin, cold air to their new home? These questions have no answers. The swarming of the Himalayan giant honeybee has never been documented by science. It happens somewhere in the vast, trackless expanse of the world's highest mountain range, hidden from human eyes by distance and elevation and the sheer impossibility of being in the right place at the right time. The Gurung have their own explanations. They say that when a new queen emerges, the old queen does not leave, she transforms. Her abdomen elongates, her wings shrink, her exoskeleton darkens to a deeper, richer black. She descends from the comb and burrows into the rock of the cliff itself, becoming one with the mountain that has sheltered her colony for so many generations. There, in the cold darkness of the granite, she waits, not dead but dormant, until the cycle of ages brings her forth again. This is myth, of course, but like all myths, it encodes a deeper truth. The queen is not an individual, she is a lineage. The same genetic lineage that built the first black wax comb on the first Himalayan cliff millions of years ago continues today in the bodies of every queen currently laying eggs in every colony currently clinging to every cliff from Bhutan to Himachal Pradesh. The queen does not die. She persists. She is the shadow within the shadow. We have examined the black wax and the black soldiers. We have visited the queen in her egg-laying trance. Now we must consider the most mysterious element of the colony's architecture, the element that is not built, not defended, not reproduced, but accumulated. The honey. Not the familiar golden syrup of the European honeybee, but something altogether stranger. The honey of Apis laboriosa is not yellow, it is red. A deep, translucent crimson, like garnet held up to light. It is thinner than ordinary honey, almost syrupy, and it possesses a faint, distinctive odor, earthy, slightly fermented, with an undertone of something sharp and medicinal. This is the famous mad honey of the Himalayas, known to the Gurung as Rado Maha and to pharmacologists as granotoxin-contaminated honey. Its psychoactive properties have been documented for millennia, described in ancient Sanskrit texts and Greek military histories, exploited by Nepalese mercenaries and Tibetan shamans. Its source is not the bees themselves but the flowers they visit, the rhododendron. The Himalayan rhododendrons, particularly Rhododendron arboreum, R. barbatum and R. campanulatum, produce nectar containing granotoxins, a class of neurotoxins that bind to sodium channels in cell membranes. These toxins do not harm the bees. Insects are largely immune to their effects. But when concentrated in honey and consumed by mammals, including humans, they produce a characteristic syndrome: salivation, sweating, dizziness, blurred vision, and, at higher doses, hallucinations, unconsciousness, and respiratory paralysis. The effects are dose-dependent and highly variable. A teaspoon of mad honey may induce nothing more than a pleasant warmth and a slight dreaminess. A tablespoon can trigger vivid visual and auditory hallucinations, a sense of temporal distortion, and a floating dissociation from the body. A quarter cup can be fatal. The Gurung have used mad honey for centuries, medicinally, recreationally, and strategically. Its sale to foreign tourists is now illegal in Nepal, but the tradition persists in remote mountain villages, where knowledge of harvest timing and dosage is passed from father to son. The honey is not intoxicating when freshly harvested. It requires several months of aging, during which the granotoxins apparently undergo a chemical transformation that enhances their psychoactivity. A properly aged mad honey, stored in sealed bamboo cylinders in the cool darkness of a Gurung home, is said to produce visions that are not merely hallucinations but revelations, glimpses of the spirit world that lies just beyond the veil of ordinary perception. The bees, of course, have no interest in human spirituality. They collect rhododendron nectar because it is abundant, because it flows at precisely the time of year when their colonies are expanding most rapidly, and because the mountains offer few alternative forage sources. The red honey is an accident of biochemistry, a side effect of the ancient coevolutionary relationship between rhododendron and bee. But it is an accident with profound consequences. The red honey is the colony's most valuable resource, not energetically, for its sugar content is no higher than that of ordinary honey, but strategically. It is the currency of coexistence between Apis laboriosa and Homo sapiens. For thousands of years, the Gurung have climbed the cliffs to harvest this honey, risking their lives on fragile ladders of twisted bamboo and hand-woven nettle fiber. They do not do this for mere sweetness. They do it for the red honey's unique properties, its medicinal and ritual significance, its power to alter consciousness and connect the mundane world to the sacred. And in exchange for this harvest, the Gurung leave the colonies alone. This is not a formal agreement, not a treaty negotiated between species. It is an emergent equilibrium, stabilized by generations of reciprocal adaptation. The bees that nest on cliffs accessible to human harvesters have evolved greater defensiveness, more potent venom, more elaborate shimmering displays. The humans have evolved, culturally rather than biologically, a set of rituals and taboos that minimize colony disturbance. Specific phrases to be spoken before climbing, specific offerings to be left at the base of the cliff, specific seasons for harvest that avoid the most vulnerable periods of the colony's reproductive cycle. Both species have shaped each other. Both have learned, imperfectly but persistently, to coexist. This is the true architecture of darkness. Not the wax, not the soldiers, not the queen's fecundity, though all of these are essential components. The true architecture is the invisible web of relationships that connects the black wax city on its cliff to the rhododendron forest below, to the Gurung villages in the valley, to the Himalayan ecosystem that encompasses them all. This web is fraying. The rhododendrons are blooming earlier, as we have noted, disrupting the synchronization of nectar flow and colony growth. The Gurung are changing too. Young people migrate to Kathmandu or abroad, seeking education and employment, and the traditional knowledge of cliff harvesting, the precise techniques, the ritual observances, the intimate familiarity with individual colony locations, is not being transmitted to the next generation. The honey hunters are aging and there are few apprentices to take their place. And the climate continues to warm, the glaciers continue to retreat, the monsoon continues to destabilize. The entire Himalayan ecosystem, one of the most biodiverse and ecologically complex regions on Earth, is undergoing a transformation whose ultimate trajectory no one can predict. The Black Wax City endures for now. Its soldiers maintain their vigil, its queen continues her endless labor, its foragers navigate the thinning air in search of rhododendron blossoms that bloom when and where they should not. But the architecture of darkness is no longer stable. The invisible web is stretching, tearing, losing its resilience. We do not know how this story ends. The final chapter has not yet been written, but we know with increasing certainty that we are living through it. The black wax city remains on its cliff, a shadow against the stone. The soldiers continue their dance. The queen continues her labor. The foragers continue their desperate search for blossoms that are no longer where they should be. The architecture of darkness holds. For now. There is a valley in the Annapurna Massif that does not appear on any map. The Gurung know it as Rado Kola, the Red River, named not for the color of its water but for the blossoms that carpet its slopes each spring. Here, at altitudes between 2,500 and 3,500 meters, the rhododendron forests achieve their densest, most extravagant expression. The trees grow not in scattered groves but in continuous stands, their twisted branches interlocking to form a canopy so thick that sunlight reaches the forest floor in scattered coins of gold. In March and April, when the blossoms open, the entire valley is transformed. The deep green of the rhododendron leaves is overwhelmed by a profusion of crimson flowers, each bloom a cluster of bell-shaped coronets, their stamens dusted with pollen the color of old honey. The air in Rado Kola during flowering season is thick with scent. It is not the sweet, cloying perfume of jasmine or rose. Rhododendron nectar has a sharper, more complex aroma, with undertones of camphor and resin and something else, something faintly acrid, almost medicinal. This is the smell of grainotoxin, the molecule that transforms ordinary honey into an agent of altered consciousness. The Gurungs say that this scent is the breath of the forest itself. They say that to inhale it deeply is to invite the forest into your lungs, your blood, your dreams. They say that the bees who drink from these blossoms are not merely collecting nectar. They are absorbing the memory of every shaman, every honey hunter, every soul who has ever climbed these cliffs or walked these forests. They say that the red honey is not made. It is distilled over generations from the accumulated wisdom and longing of an entire people. These are metaphors, of course, but like all deep metaphors, they point toward a truth that literal description cannot capture. The truth is that grainotoxin is one of the most fascinating and poorly understood neuroactive compounds in the natural world. Its mechanism of action is deceptively simple. Voltage-gated sodium channels, the microscopic pores and nerve cell membranes that initiate and propagate electrical impulses, normally open in response to depolarization and then rapidly inactivate, closing the channel and preventing further sodium influx. Grainotoxin binds to a specific site on these channels and prevents their inactivation. The channels remain open, sodium continues to flow, and the affected neurons fire continuously and uncontrollably. The physiological consequences of this uncontrolled firing depend on dose and route of administration. In small amounts, grainotoxin produces a characteristic triad of symptoms: salivation, sweating, and dizziness. These are the classic signs of mad honey intoxication, recognizable to any emergency physician in the Himalayan foothills during the spring honey harvest season. In larger amounts, the effects become more profound. Blood pressure drops dramatically as peripheral blood vessels dilate. Heart rate slows, sometimes to dangerously low levels. Vision blurs and doubles. The boundaries between objects seem to waver and dissolve. Sounds become distorted, their pitch and timbre shifting unpredictably. The sense of time, that most fundamental of cognitive constructs, loses its reliable, linear progression. Seconds stretch into minutes, minutes collapse into moments. At still higher doses, the hallucinations begin. They are not the vivid, narrative hallucinations associated with psychedelic compounds like LSD or psilocybin. Granotoxin hallucinations are more fragmentary, more sensory than cognitive. Users report seeing colors that do not exist, hearing melodies that have never been composed, feeling the presence of presences that cannot be named. The boundaries between self and world blur. The skin becomes permeable, the ego porous. Some describe a sensation of floating, of weightlessness, of detachment from the physical body. Others report a profound sense of connection to the forest, to the mountains, to the ancestors who walked these slopes before them. At the threshold of lethality, consciousness itself begins to fragment. Respiratory muscles falter. The drive to breathe weakens. Cardiac arrhythmias develop, the heart's rhythmic contractions giving way to chaotic, ineffective quivering. Unconsciousness descends, then coma, then, if medical intervention does not arrive in time, death. This is the molecule that Apis laboriosa concentrates in its honey. This is the substance that the Gurung have harvested, traded, and revered for millennia. This is the mad honey. But to understand the red honey only in terms of its pharmacology is to miss the point entirely. The molecule is merely the mechanism. The meaning lies elsewhere. The first Western account of mad honey intoxication appears in the works of Xenophon, the Athenian soldier and historian who chronicled the retreat of the 10,000 through Persian territory in 401 BCE. In Book 4 of the Anabasis, he describes an incident that occurred near Trebizond, on the southeastern coast of the Black Sea. The soldiers who ate of the honeycombs all lost their senses, and were seized with vomiting and diarrhea, and not one of them could stand upright. Those who had eaten a little behaved like men greatly intoxicated, and those who had eaten much like madmen or even like dying persons. They lay upon the ground in great numbers as if there had been a defeat, and there was general dejection. Yet no one died, and about the same hour on the next day they began to come to their senses, and on the third or fourth day they got up, as if from a drugging. Xenophon did not know the source of this strange intoxication. He did not know that the honey had been collected by bees foraging on Rhododendron ponticum, a close relative of the Himalayan species, whose nectar contains the same granotoxins. He did not know that the soldier's recovery was due to the rapid metabolism of these toxins, which are processed and eliminated by the human body within 24 to 48 hours. But he recognized something essential. This honey did not merely intoxicate, it transformed. His soldiers did not behave like men who had drunk too much wine. They behaved like men who had crossed some threshold, visited some other state of being, and then, miraculously, returned. 2,400 years later, the Gurung honey hunters described their own encounters with mad honey in remarkably similar terms. They do not speak of getting high or drunk. They speak of Duta Sangha, meeting with the gods. They speak of Atmakeo Yatra, the journey of the soul. They speak of Maya Keo Radodhara, the red stream of love. This is not, I think, mere poeticism. It is a different epistemology, a different way of understanding the relationship between plant, animal, human, and molecule. Where Western pharmacology sees a toxin that disrupts normal physiological function, Gurung tradition sees a medicine that restores balance between the material and spiritual worlds. Where Western medicine prescribes avoidance and treatment, Gurung shamans prescribe intentional use under controlled conditions, guided by elders who have walked the red path before. Both perspectives are valid. Both are incomplete. The mad honey is simultaneously a poison and a sacrament, a threat and a gift, a product of biochemistry and a vehicle of transcendence. It is all of these things because we, humans, bees, rhododendrons, have co-evolved into a relationship so complex and intimate that none of its dimensions can be understood in isolation. The bees do not know that the nectar they collect contains a molecule that will alter the consciousness of the mammals who consume their honey. The rhododendrons do not know that their chemical defense against herbivores has been appropriated by a species of primate for purposes of ritual and recreation. The Gurung do not know, cannot know, the full biochemical cascade that transforms granotoxin-bound sodium channels into visions of ancestors and gods. And yet, all of these actors have found each other. All have adapted, responded, evolved in relation to the others. The mad honey is not a thing. It is a relationship. It is the condensed history of millions of years of coevolution, distilled into a red syrup that a man can hold in the palm of his hand. This is the true mystery of the mad honey. Not the molecule but the meaning. Not the mechanism but the relationship. Not the poison but the sacrament. The village is called Gandrik, though this is not its true name. Its true name, the name spoken only among Gurung elders, never written, never recorded, is a secret that travelers are not permitted to know. It clings to a ridge at 2,000 meters, overlooking the deep gorge of the Modi Kola River. To the north, the peaks of Annapurna South and Hyunchali rise in an unbroken wall of ice and granite. To the south, the forested hills descend in endless waves toward Pokhara and the flatlands beyond. Gandrik is not a large village. Perhaps 200 stone and slate houses, their roofs weighted against the winter gales, their walls plastered with a mixture of clay and yak dung that dries to the color of old bone. Narrow alleys wind between the houses, paved with irregular flagstones worn smooth by generations of bare feet. Water spouts carved in the shape of makaras, mythical serpent elephants, trickle continuously into stone cisterns. Prayer flags, their colors faded to pastels by sun and snow, snap in the wind from every rooftop and ridgeline. I came to Gandrik not as a scientist but as a listener. I came with no hypothesis to test, no data to collect, no specimens to preserve. I came because I had read the old accounts, Xenophon's soldiers, the Turkish beekeepers, the Nepalese shamans, and I had understood, with the kind of certainty that precedes evidence, that the mad honey could not be understood in a laboratory. It had to be experienced, not consumed. I was not brave enough or foolish enough for that, but witnessed, attended, received. My guide was a man named Hira Gurung. He was 73 years old, though his face, weathered to the texture of rhododendron bark, could have belonged to a man of any age between 50 and 90. His eyes were the color of Himalayan tar, dark brown, almost black, with a peculiar stillness that I came to recognize as the signature of someone who has spent a lifetime looking at very small things from very great heights. Hira had been a honey hunter since childhood. His father had been a honey hunter, and his father's father, and his father's father's father, back across 14 generations to the first Gurung who had climbed a cliff and returned with a bamboo cylinder of red honey. He had been stung more times than he could count. He had fallen twice, once from 15 meters, once from 30, and had survived both impacts through a combination of luck, soft snow, and the intercession of ancestors whose names he recited to me in a voice so matter-of-fact that it took me several minutes to realize he was praying. The evening before the harvest, Hira invited me to his house. It was a traditional Gurung dwelling, ground floor for livestock, first floor for living, second floor for storage and sleeping. We sat on the first floor, cross-legged on woven mats, while his wife, a woman of perhaps 60 whose name I never learned, because it is not Gurung custom to offer the names of women to strangers, fed us rice dal and pickled radish and a thin, slightly sour vegetable curry made from the tender shoots of mountain ferns. The food was simple but perfect, each flavor distinct and self-contained, like the notes of a well-tempered scale. After the meal, Hira produced a bamboo cylinder. It was about 30 centimeters long and 8 in diameter, sealed at both ends with plugs of twisted cloth. The bamboo itself was old, decades old, perhaps centuries, its surface darkened and polished by countless handlings. He held it with both hands, not possessively but reverently, the way a priest might hold a reliquary containing the bones of a saint. "This," he said, "is the honey of my grandfather's grandfather." He did not explain further. He did not need to. The cylinder contained not honey but history, 14 generations of knowledge compressed into a single viscous fluid. The granotoxins had long since degraded. This honey, if it could still be called honey, would not intoxicate or enlighten. It was a relic, not a medicine. But it was also a covenant, a promise made by the living to the dead and by the dead to the living. We will continue. We will remember. We will climb. Hira uncapped the cylinder and dipped his index finger into the dark red syrup within. He raised his finger to the lamp, a simple wick floating in mustard oil, and for a moment the honey caught the light, gleaming like a ruby held before a flame. "This color," he said, "this is the color of the rhododendron flower in full bloom. This is the color of the blood that flows from the mountain's heart. This is the color of the setting sun when it touches the highest peaks. This is the color of the red honey. This is the color of our people. He touched his finger to his tongue. He did not close his eyes. He did not enter a trance. He simply sat, still and silent, for perhaps 30 seconds, while the ghost of his grandfather's grandfather's grandfather whispered to him in a language I could not hear. Then he recapped the cylinder, wrapped it in a strip of faded cloth, and returned it to the niche in the wall where it had rested for generations. The honey hunters will gather at the base of the cliff tomorrow, he said. You will come with us. You will see what we see, but you will not climb. That is not your path. It was not a request. It was not an invitation. It was a statement of fact, delivered with the same calm certainty that he had used to describe his falls from cliffs 15 and 30 meters high. I nodded. There was nothing else to do. The cliff was called Beautiful Danda, the ridge where the ghosts rest. It rose from the eastern flank of the Moti Kola Gorge, a vertical wall of dark gray granite striated with bands of quartz that caught the morning light and threw it back in shards of broken silver. At its base, a narrow terrace of compressed scree provided the only level ground for kilometers in any direction. Here, the honey hunters had gathered since time beyond memory. There were 6 of them, ranging in age from perhaps 16 to perhaps 70. They wore no specialized gear, no helmets, no harnesses, no carabiners. Their only equipment was coiled at their feet, ladders of twisted bamboo, each rung lashed to the uprights with hand-woven nettle fiber, long poles tipped with curved iron sickles, cylindrical baskets of woven cane open at both ends, designed to hold the honeycombs they would cut from the rock. They did not speak. They did not consult. They simply waited, facing the cliff, while the sun climbed behind them and the shadow of the ridge retreated up the granite face. At precisely the moment when the first direct sunlight struck the overhang where the colony hung, I could see it now, a black smear against the gray, larger than I had imagined, larger than anything I had imagined. Here a Gurung stepped forward. He raised his right hand, palm outward, and spoke. The words were Gurung, but a form of Gurung so archaic that even the other hunters, I later learned, understood only fragments. It was a prayer, a negotiation, an apology, a plea. It addressed the bees by names I had never heard and have now forgotten. It acknowledged their prior claim to the cliff, their ancient tenure, their sacrifice. It promised that the harvest would be just. Not too much, not too little, not taken from the heart of the colony where the queen lay brooding her endless eggs. It asked permission, and it offered gratitude, and it swore in the name of 14 generations of Hira's ancestors that the covenant would be honored. Then he lowered his hand, and the honey hunters began to climb. The ladder is called Ching in the Gurung language, though the word also means bridge, and in certain contexts, path and destiny. It is constructed from a single species of bamboo, nigalo, a high-altitude variety that grows in dense thickets between 2,000 and 2,500 meters. Its culms are thinner and more flexible than the giant bamboos of the lowlands, but they possess extraordinary tensile strength. A well-made chain can support the weight of a fully grown man and the 40 kilograms of honey he carries down from the cliff. The construction of a chain is itself a ritual. The bamboo must be harvested during the waning moon, when the sap has retreated to the roots and the culms are at their driest and strongest. The harvester must fast for 24 hours before cutting, and must speak no word from the moment he enters the grove until the moment he emerges with his bundle of culms. The nettle fiber used for lashing must be gathered by a virgin, a boy or girl who has not yet reached puberty, and twisted into cordage during a single, uninterrupted session that begins at dusk and ends at dawn. These are not practical requirements. A bamboo culm harvested at the wrong lunar phase is structurally identical to one harvested at the right phase. Nettle fiber twisted by a virgin is chemically indistinguishable from nettle fiber twisted by a grandmother. The restrictions are not about material properties, they are about intentionality. They ensure that every chain is not merely a tool but an offering, a prayer made visible, a bridge not only between the climber and the cliff but between the human world and the world of the bees. The chain that Hira Gurung's team deployed that morning was approximately 40 meters long. It had been assembled on the terrace over the course of several hours, each section of bamboo lashed to the next with meticulous precision. When it was complete, the youngest hunter, a boy of 16, his face smooth and his hands steady, tied a weighted cord to the upper end of the ladder and began to swing it in slow, increasing circles. This is the most dangerous moment of the entire harvest. The cord must be thrown upward, over the lip of the overhang where the colony hangs, and then retrieved, hopefully with its weighted end caught on some protrusion of the rock. If the throw is too short, the cord falls back empty. If it is too long, it sails past the overhang and drops uselessly on the other side. If it is poorly aimed, it may strike the comb itself, agitating the colony and triggering a mass defensive response that can send climbers, ladder, and all plummeting to the scree below. The boy threw. The cord arced upward, tracing a perfect parabola against the flawless blue sky. It cleared the lip of the overhang by perhaps a meter, then dropped. For a moment nothing happened. The cord hung limply against the rock face. Then the boy pulled gently and the weighted end caught, not on a protrusion as I had assumed, but on something else. Something that moved. One of the soldier bees, alerted by the vibration of the cord against the rock, had seized it with its mandibles. Not in defense. The attack response is immediate and unambiguous, but in curiosity or perhaps in recognition. The bee held the cord for perhaps 5 seconds, its antennae tracing the unfamiliar texture of the twisted fiber. Then it released, and the weighted end dropped another centimeter before wedging securely in a hairline crack. The boy looked at Hira. Hira looked at the cliff. No one spoke. No one needed to. The bee had accepted the offering. The covenant was renewed. The climb itself took nearly an hour. The boy went first. He ascended the chain with the fluid, boneless grace of a creature more arboreal than terrestrial, his bare feet gripping the bamboo rungs with prehensile confidence. Behind him came an older man, perhaps 40, carrying the harvesting pole and the collection basket. Behind him came Hira, moving slowly but steadily, his weathered hands finding holds that seemed invisible to my untrained eyes. At the top of the ladder, the overhang created a narrow ledge, no more than 30 centimeters wide, sloping slightly outward, coated with a fine dust of desiccated lichen and the accumulated guano of generations of bees. The boy stepped onto this ledge without hesitation, pressed his back against the granite and began to work. The harvesting pole was approximately 3 meters long, its distal end fitted with a curved iron blade honed to razor sharpness. The boy inserted this blade behind the comb, at its uppermost attachment point, and began to saw, not aggressively but patiently, with the same slow rhythmic motion that his ancestors had used for 1400 generations. The bees responded immediately. A wave of soldiers poured over the edge of the comb, their bodies forming a living curtain between the intruder and the brood. They did not attack, they postured. Their abdomens flexed in the characteristic shimmering display, creating that stroboscopic blur that the Gurung call the dance of the shadow. The sound of their wings, thousands of wings beating in defensive synchrony, rose to a pitch that was almost painful, a high-frequency whine that seemed to bypass the ears and resonate directly in the bones of the skull. The boy did not flinch. He continued sawing, his stroke steady, his breathing calm. He did not look at the bees. He did not look at the drop below him. He looked only at the interface between comb and rock, his entire consciousness focused on the precise angle and pressure required to separate the colony's architecture from its foundation without causing structural collapse. After perhaps 5 minutes, the attachment gave way. The boy caught the falling comb with his free hand, its weight, perhaps 8 kilograms of wax, honey, and living bees, swinging against his hip with the momentum of its release. He transferred the harvesting pole to his other hand, passed the comb to the man behind him, and began the same process on the next attachment point. He would repeat this sequence 7 times before the harvest was complete. He would cut 7 combs from the cliff, each weighing between 5 and 12 kilograms, each containing thousands of bees and liters of red honey. He would transfer each comb to his partner, who would place it in the collection basket and lower it by cord to the waiting hands on the terrace below. He would receive, by my rough count, approximately 200 stings during the course of this work. He did not wear protective clothing. He did not smoke the bees, a technique used by lowland beekeepers to pacify colonies, but ineffective and counterproductive at this altitude, where the thin air disperses smoke too quickly to have any effect. He simply endured, his skin swelling with venom, his blood absorbing granotoxins with every sting, his consciousness maintained in that narrow channel between acute pain and dissociative shock through a discipline of attention that I could only witness and admire. When he finally descended, an hour and 40 minutes after he had begun his climb, his face was so distorted by edema that I barely recognized him. His eyes were swollen shut. His lips had doubled in size. His hands, gripping the bamboo rungs with undiminished strength, resembled the paws of some strange semi-aquatic mammal rather than human extremities. He stepped off the ladder onto the terrace, walked 3 paces to a flat rock that had clearly been used for this purpose for generations, and sat down. Someone handed him a ceramic cup of salted butter tea. He drank it slowly, methodically, while the swelling continued to spread across his face and down his neck. His breathing was steady. His pulse, when I surreptitiously checked it, was slow and regular. He did not speak. He did not need to. After perhaps 10 minutes, he opened his eyes. "They are strong this year," he said. "The colony is healthy. The queen is laying well." Then he stood up, walked to the collection baskets where the harvested combs awaited processing, and began to extract the red honey. The processing of the honey is women's work. This is not a restriction but a recognition. The men risk their lives on the cliffs. The women transform that risk into sustenance. The men bring down the raw comb, dripping with venom and alive with angry bees. The women render it into medicine, food, and sacrament. Neither task is subordinate to the other. Neither is possible without the other. The covenant between humans and bees is mirrored by the covenant between men and women, and both are equally sacred. Hira's wife, whose name I still did not know, whose voice I had still not heard, presided over the processing with the quiet authority of a master craftsman. She had done this work for 50 years. Her mother had done it before her. Her grandmother, her great-grandmother, her great-great-grandmother, back across the same 14 generations that Hira had invoked in his prayer at the base of the cliff. The combs were laid out on a flat surface of polished slate, their hexagonal cells gleaming with the dark red syrup that gave the mad honey its name and its power. Using a curved knife of the same design as the harvesting sickles, but smaller and finer, the women scraped away the wax caps that sealed each cell. The caps were set aside in a separate basket. They would be melted down and used for sealing containers, for waterproofing cordage, for 100 other purposes that sustained life in this vertical landscape. Then the combs were crushed. Not with machines. There are no machines in Gandrik that could perform this task, but with the hands. The women kneaded the wax and honey together, squeezing and releasing, their fingers moving in a rhythm that seemed to predate language itself. The honey flowed from the crushed cells in a viscous red stream, collecting in depressions worn into the slate by centuries of similar work. This honey was not the clear, filtered product familiar to Western consumers. It was thick, opaque, filled with fragments of wax and pollen and the occasional detached wing or leg of a bee that had given its life in defense of its colony. It was raw, alive, unprocessed. And it was, the women assured me, infinitely more powerful than the strained honey sold to tourists in Pokhara and Kathmandu. "This honey," Hira's wife said, her first words to me, spoken in a voice as weathered and resonant as her husband's, "this honey remembers everything. It remembers the flower where it was born. It remembers the bee who carried it home. It remembers the sting of the soldier who died to protect it. When you eat this honey, you eat the memory of the mountain." She dipped her finger into the flowing red stream and raised it to her lips. I watched her face as the honey dissolved on her tongue. She did not close her eyes. She did not enter a trance. She simply sat, still and silent, for perhaps 30 seconds, while the accumulated memory of 10,000 generations of rhododendron blossoms and honeybee foragers and soldier sacrifices whispered to her in a language that only women of her lineage could understand. Then she opened her eyes, looked directly at me and said, "You will not taste this honey. Not today. Not ever. It is not your medicine. It is not your memory. You may witness, you may record, you may tell your people what you have seen, but you will not consume. That is not your path." It was not a judgment. It was not a rejection. It was simply a statement of fact, delivered with the same calm certainty that Hira had used when he told me I would not climb. I nodded. There was nothing else to do. The processed honey was poured into bamboo cylinders similar to the one Hira had shown me the previous evening. These cylinders were not relics. They were containers, functional and replaceable. But they would, over the coming decades and centuries, become relics in their own right, repositories of memory and medicine, passed from generation to generation, their contents aging and transforming as the grainotoxins slowly degraded into other, more complex molecules. Some of this honey would be consumed within the village, used for ritual purposes and medicinal treatments. Some would be traded to neighboring communities, Tibetan refugees who valued its warming properties, lowland merchants who paid premium prices for its psychoactive effects, the occasional foreign researcher like myself who offered cash in exchange for samples that would be analyzed in distant laboratories. Some would be stored, sealed in the cool darkness of Gurung homes, waiting for grandchildren and great-grandchildren who had not yet been born. All of it, every drop, was the product of the covenant. The bees provided the raw material, the rhododendrons provided the nectar, the mountains provided the cliffs, the men provided the risk, the women provided the skill. The mad honey was not a commodity, it was a collaboration, a co-creation, a contract signed not in ink but in venom and sweat and the slow accumulation of generations. And now that contract is being broken. Not by the bees, not by the rhododendrons, not by the mountains, by us, by the species that calls itself Homo sapiens, the wise primate, the self-appointed steward of planetary biodiversity. The climate is warming. The rhododendron forests are migrating upward, their lower limits retreating, their upper limits advancing into altitudes where the bees cannot follow. The monsoons are destabilizing, their life-giving rains arriving unpredictably or not at all. The honey hunters are aging and their children are leaving for the cities, trading the cheng and the harvesting sickle for smartphones and service industry jobs. The covenant is fraying. The threads that have bound bees and humans, rhododendrons and mountains, men and women and ancestors and descendants, are snapping one by one. The mad honey is still being harvested, this season, next season, perhaps for a few more seasons after that. But the trajectory is clear. The red stream is running dry. Hira Gurung knows this. His wife knows this. The 16-year-old boy who climbed the Cheng with such fluid grace, who endured 200 stings and descended with his face swollen beyond recognition, knows this. They do not speak of it directly, that is not their way. But it is present in every prayer, every offering, every careful negotiation with the bees at the base of the cliff. We will continue. We will remember. We will climb. For now, there is a moment in every honey hunter's life that he never describes, not to his sons, not to his grandsons, not to the foreign researchers who come with notebooks and recording devices and eyes full of questions he cannot answer. It is not a secret, not in the sense of something deliberately withheld. It is simply inexpressible, a point of transition so fundamental that language, which evolved to describe the shared world of human experience, cannot reach it. This moment occurs approximately 30 seconds into the climb. The hunter has left the terrace. He has ascended the first few meters of the cheng, his weight settling onto the bamboo rungs, his hands finding their familiar grip on the uprights. The sound of the wind has changed. It is no longer an external force but a medium, a fluid through which he moves. The weight of his body, which on solid ground feels like a permanent condition, has become negotiable, a variable in an equation whose other terms are friction, tension, and the subtle elasticity of twisted nettle fiber. At this moment something shifts. The hunter ceases to be a man climbing a ladder. He becomes, instead, a point of awareness suspended between earth and sky. His body continues its work, hands reaching, feet finding purchase, weight transferring, but this work no longer requires his conscious attention. It has been delegated to muscles and nerves that have performed these same movements thousands of times, across decades, across generations. His conscious mind, freed from the tyranny of moment-to-moment survival, opens itself to other perceptions. He feels the ladder breathing. This is not a metaphor. A well-made ching, constructed from properly harvested nigolo bamboo and lashed with virgin twisted nettle fiber, responds to the wind not as a rigid structure but as a living organism. It flexes, it yields, it accommodates. The creaks and groans that terrify inexperienced climbers are not warnings of imminent failure. They are the ladder's way of speaking, of communicating its limits and capacities. A hunter who has learned this language can feel, through his hands and feet and the subtle shifts of his center of gravity, exactly how much tension the ladder can bear, exactly how far it can bend before it breaks. At this moment, the hunter also hears the bees. Not with his ears. The wind and the creaking bamboo are too loud for that. He hears them through his skin, through the fine hairs on his arms and the soles of his bare feet. The low-frequency drone of the colony, that deep, resonant hum that seems to emanate from the rock itself, is not a sound but a vibration, conducted through the granite of the cliff, through the bamboo of the ladder, through the living tissue of his own body. He feels the colony's emotional state as directly as he feels his own heartbeat, calm, alert, watchful. This is the moment of transition. This is the threshold. This is the place where the honey hunter becomes something other than what he was on the ground. To understand the honey hunters, one must understand not only what they do but what they carry. The equipment of a Gurung honey hunter is extraordinarily simple. A ching, the bamboo ladder. A harvesting pole, 3 meters of seasoned wood, fitted with a curved iron blade. A collection basket, woven cane, open at both ends, designed to hold the heavy cones during the descent. A length of cord, hand-twisted nettle fiber, strong enough to support a man's weight but light enough to be thrown with precision. A small cloth bundle containing offerings for the bees and the mountain spirits. Rice, vermilion powder, a few coins, a sprig of juniper. That is all. No harnesses. No helmets. No ropes or carabiners or mechanical ascenders. No protective clothing. Not even gloves, which would compromise the climber's grip on the bamboo and his sensitivity to the latter's subtle vibrations. The honey hunters faced the cliff with nothing between their skin and the abyss but the accumulated knowledge of 1,400 generations. This is not a matter of poverty or technological backwardness. Modern climbing equipment is available in Pokhara and Kathmandu. A few expeditions have even offered to donate harnesses and helmets to the honey hunting communities. The hunters have consistently refused. Why? I asked Hira Gurung one evening, as we sat outside his house watching the sunset set fire to the Annapurna Massif. He considered the question for a long time. Not because he was searching for an answer, I realized, but because he was searching for a way to translate an answer that had no equivalent in English. The harness, he said finally, would keep me from falling. Yes, this is what it is designed to do. But it would also keep me from feeling the cliff. It would place a layer of nylon and metal between my body and the rock. It would tell me, you are separate from this place. You are a visitor here, a trespasser, protected by your technology from the consequences of your intrusion. He paused, his weathered face catching the last copper light of the dying sun. But I am not a visitor. I am not a trespasser. My ancestors have climbed this cliff for 1,400 generations. My body carries their memory. My blood carries their courage. My hands, my feet, my skin, these are the tools my father gave me and his father gave him and his father gave him back across the generations to the first hunter who looked at this cliff and said, I will climb. He turned to face me directly. The harness would protect my body, but it would sever my connection to my ancestors. It would tell the bees, this man does not trust the covenant enough to face you without armor. It would tell the mountain, this man is afraid of you. And when you are afraid of the mountain knows. And the mountain does not forgive. This is not superstition. It is not primitive animism or pre-scientific credulity. It is a coherent epistemology, a way of knowing and relating to the non-human world that is radically different from the Western scientific paradigm but no less valid within its own context. The honey hunters do not believe that the mountain is a sentient being with intentions and emotions. They believe something far more subtle, that the relationship between human and mountain, like any long-term relationship, is built on trust, reciprocity, and mutual respect. To introduce protective equipment into this relationship is not merely to change the material conditions of the climb. It is to change the fundamental nature of the relationship itself. It is to say, I no longer trust you enough to approach you unprotected. And once that trust is broken, it cannot be restored. This is why the honey hunters continue to use chengs made from nigalo bamboo and nettle fiber, even though modern synthetic ropes are stronger, lighter, and more durable. This is why they continue to harvest honey with curved iron blades forged by village blacksmiths using techniques transmitted across generations, even though stainless steel knives from factories in China would cut more cleanly and require less frequent sharpening. This is why they continue to climb barefoot, even though boots with Vibram soles would provide better traction on lichen-covered granite. The technology is not the point. The relationship is the point. The covenant is the point. And the covenant is maintained not despite the danger but through the danger. Consider the cheng. A 40-meter ladder of twisted bamboo, lashed with hand-woven nettle fiber, suspended from an overhang on a vertical cliff face. In wind speeds that regularly exceed 40 kilometers per hour. At an altitude of 3,000 meters, where the air contains 40% less oxygen than at sea level and human cognitive function begins to degrade. From an engineering perspective, this is absurd. The tensile strength of nettle fiber is a fraction of that of modern nylon. The compressive strength of nigalo bamboo is a fraction of that of aircraft-grade aluminum. A single frayed lashing, a single hairline crack in a single comb, a single moment of inattention in the annual inspection and maintenance of the ladder, any of these could cause catastrophic failure. And yet, the cheng does not fail. In the 1400 generations that the Gurung have been harvesting honey from these cliffs, there is no record, oral, written, or legendary, of a properly constructed and maintained cheng breaking under the weight of a climber. Hunters have fallen, yes. Ladders have been dislodged by rock falls, swept away by avalanches, deliberately collapsed to prevent access by unauthorized harvesters. But the cheng itself, the living, breathing artifact of bamboo and fiber, has never betrayed a hunter who trusted it. This is not magic. It is not divine intervention. It is the accumulated wisdom of 1400 generations, encoded in every stage of the cheng's construction. The lunar phase harvesting of the bamboo, the pre-dawn gathering of the nettle fiber, the all-night twisting session, the meticulous inspection of every culm and every lashing before each climb. It is knowledge so refined, so deeply internalized, that it has become instinct, not conscious, not verbal, not transferable except through the patient apprenticeship of observation and imitation. And it is disappearing. Dilip knows how to construct a cheng. His father taught him, as his grandfather taught his father, as his great-grandfather taught his grandfather. But Dilip has never constructed one himself. The cheng he climbs was built by his father, and before that by his grandfather, and before that by his great-grandfather, each generation adding new culms, replacing worn lashings, maintaining the living artifact that connects them to their ancestors and to the cliff. When this cheng finally fails, not catastrophically but through the slow accumulation of age and wear, Dilip will be faced with a choice. He can attempt to build a new cheng, drawing on knowledge that he has received but never practiced. He can attempt to repair the old cheng, extending its life for another generation. Or he can abandon the cheng altogether, replacing it with synthetic ropes and aluminum ladders, severing the connection that has bound his people to this cliff for 40,000 years. He does not know which choice he will make. He does not know if he will have a choice at all. The young people are leaving, he told me, his voice barely audible above the wind. My cousins, my friends, the boys I grew up with, they have gone to Pokhara, to Kathmandu, to Dubai and Qatar and Malaysia. They work in hotels and restaurants and construction sites. They send money home to their families. They will never climb a chem. They will never harvest honey. They will never stand on this terrace and feel the vibration of the colony through the rock. He paused, his dark eyes fixed on the cliff face where his father had climbed and his grandfather had climbed and his great-grandfather had climbed, back across 1400 generations to the first hunter who had looked at this cliff and said, "I will climb. When I am gone," he said, "there will be no one left to remember." The harvest that day was not unusual. It was, by the standards of the Gurung honey hunters, entirely ordinary. Dilip climbed first. He ascended the Cheng with that same fluid, boneless grace I had observed the previous day, his bare feet finding the bamboo rungs with the confidence of long practice. Behind him came his uncle, not his father's brother who had died on the moraine 3 years ago, but his mother's brother, a man of about 40 who had been harvesting honey since he was Dilip's age. Behind him came Hira, moving slowly but steadily, his weathered hands gripping the ladder with the patience of a man who has learned that haste is the enemy of survival. At the top of the ladder, the overhang created that narrow ledge, 30 centimeters of sloping granite, coated with lichen dust and biguano. Dilip stepped onto it without hesitation, pressed his back against the rock and began to work. The colony was calm. The soldiers performed their shimmering display, that stroboscopic dance of flexing abdomens that the Gurung call Chaya Keo Nritya, but they did not attack in force. A few dozen bees launched themselves at Dilip's face and hands, driving their stingers into his skin with the suicidal determination that defines honeybee defense. He did not flinch. He did not swat. He simply continued sawing at the comb's attachment points, his stroke steady, his breathing calm. I watched from the terrace below, my neck craned back at an angle that would ache for days. The figures on the cliff were small, almost doll-like, their movements slow and deliberate against the vast gray expanse of the granite. The bees, invisible at this distance, manifested only as a dark haze around the hunters' heads, a living cloud of venom and sacrifice. The first comb detached. Dilip caught it with his free hand, transferred it to his uncle, who placed it in the collection basket and began the careful process of lowering it to the terrace. The basket descended in slow swaying arcs, its weight, perhaps 10 kilograms of wax, honey and living bees, pulling the cord taut against the wind. On the terrace, Hira's wife and the other women waited. When the basket touched down, they lifted out the comb and laid it on the polished slate surface. Their hands, bare and unprotected like the hunters, began the patient work of crushing the wax and extracting the red honey. This scene has played out in its essential elements for 40,000 years. The technology has changed, iron blades instead of stone, woven cane baskets instead of animal hide bags, bamboo cylinders instead of gourds. But the fundamental relationship between hunter, cliff, and colony remains unchanged. The man climbs, the bee stings, the honey flows. The covenant is renewed. But this time something was different. I noticed it first as a change in the soundscape. The wind, which had been blowing steadily from the northwest, shifted direction, not suddenly but gradually veering around to the southwest. With it came a new smell, not the clean, cold scent of snow and granite, but something warmer, earthier, tinged with the faint sweetness of decaying vegetation. Hira noticed it too. I saw him pause on the ledge, his harvesting sickle frozen mid-stroke, his head tilted at an angle of intense concentration. He was not looking at the comb or the bees or the cliff. He was looking at the sky. The clouds were moving fast. Too fast. The morning had been clear, the sky that flawless Himalayan blue that seems almost artificial in its purity. But now from the southwest, a bank of gray was advancing with alarming speed, its leading edge ragged and turbulent. Below it, a curtain of precipitation, rain or perhaps snow at higher altitudes, dragged across the lower slopes of Annapurna south. The harvest continued. What else could they do? The hunters were 40 meters above the terrace, suspended on a bamboo ladder lashed with nettle fiber, with no possibility of rapid descent. The colony was agitated, its soldiers already mobilized, its defensive response escalating with every cut of the sickle. To abandon the harvest now would be to waste the bee's sacrifice, to violate the covenant, to leave the cliff with nothing but wounds and an unfulfilled promise. Dilip kept cutting. His uncle kept catching and transferring. Hira kept observing, his weathered face turned toward the advancing storm, his body absolutely still except for the slow, rhythmic pulse of his breathing. The first raindrops arrived at approximately the same moment as the final comb. They were not the gentle, misting drizzle of lower elevations. They were fat, cold, driven horizontally by the wind. Each drop struck the granite with an audible tick, like a pebble thrown against a window. Within seconds, the cliff face was slick and glistening, the lichen that provided essential friction transformed into a slippery, treacherous film. Dilip's uncle began the descent first. He moved carefully, deliberately, his bare feet testing each rung before committing his weight. The bamboo, wet with rain, was more slippery than the rock itself. I saw his foot slip once, twice, 3 times, each time catching himself with a grip that seemed more luck than skill. Dilip came next. He had the collection basket with him, containing the final comb, 7 kilograms of honey and wax and living bees, swinging against his hip with each careful step. His face, already swollen from dozens of stings, was expressionless, focused, absolutely present in each moment of the descent. Hira came last. He moved even more slowly than the others, his aged hands gripping the bamboo with a patience that was almost prayerful. The rain had soaked through his thin cotton shirt, plastering it to his back. I could see the outlines of his shoulder blades moving under the skin as he transferred his weight from rung to rung. And then, 20 meters above the terrace, Dileep's uncle stopped. I did not understand why at first. His position on the ladder seemed stable. His hands and feet were securely placed. There was no visible obstacle in his path. But his body was rigid, frozen, his head tilted at that same angle of intense concentration that I had seen in Hira when the storm first appeared. Then I heard it. A low, deep rumble, not from the sky but from the mountain itself. It was not the sharp crack of rockfall or the grinding groan of glacial movement. It was something else. A vibration that seemed to emanate from the very heart of the cliff, transmitted through the granite, through the bamboo, through the bodies of the men suspended against the stone. The bees heard it too. Their defensive drone shifted pitch, rising from the steady hum of territorial warning to something higher, more urgent, almost panicked. The soldiers who had been pursuing the descending hunters abruptly broke off their attack and streamed back toward the colony, their bodies forming a dark, swirling vortex around the black wax comb. Dileep's uncle began to climb again. Not downward, upward. Back toward the ledge he had just left, back toward the colony, back toward the danger he had spent the last hour escaping. I did not understand. I could not understand. My Western mind, trained to see the world in terms of individual survival and rational self-interest, could not comprehend why a man who had just risked his life to harvest honey would voluntarily return to the source of that risk. But Dileep understood. Hira understood. Every hunter on that cliff, every man and woman who had ever participated in the harvest understood. The colony was in danger. Not from humans, the harvest was complete, the covenant fulfilled, but from the storm. The rain was soaking the comb, weighing down the wax, threatening to tear the entire structure from its precarious attachment to the overhang. The bees, for all their defensive ferocity, could not save themselves. They needed help. And the hunters who had just taken their honey were the only ones who could provide it. What happened next took approximately 4 minutes. Dileep's uncle reached the ledge and immediately began working on the comb's attachments. Not cutting, reinforcing. Using scraps of cordage from his belt, he lashed the upper edge of the comb more securely to the overhang, distributing its weight across additional attachment points. The bees swarmed around him, their bodies a living cloud, but they did not sting. They understood, in whatever way bees understand such things, that this man was not a threat but an ally. Dileep reached the ledge a moment later. He did not have cordage. His belt carried only the harvesting sickle and a small cloth bundle of offerings. But he had his hands, his feet, his body. He positioned himself beneath the comb, pressing his shoulders against its lower edge, taking some of its weight onto his own frame. The bees landed on his face, his neck, his bare arms, not stinging but clinging, their tiny claws anchoring them to his skin as the wind threatened to tear them from the comb. Hira reached the ledge last. He was 73 years old. His body, after an hour of climbing and harvesting and descending, was near its limits. But he did not hesitate. He positioned himself beside Dilip's uncle, his weathered hands finding the same fraying attachment points, his fingers working the nettle fiber into improvised reinforcements with the skill of 1400 generations. For 4 minutes, the three men worked together, human and bee, hunter and hunted, predator and prey, to save the colony from the storm. Then, as suddenly as it had arrived, the rain stopped. The wind shifted back to its prevailing northwesterly direction, pushing the storm front eastward along the Annapurna Massif. The clouds broke. Shafts of golden afternoon light penetrated the gray veil, illuminating the wet cliff face in patches of brilliant liquid gold. The bees, sensing the passing of danger, began to withdraw from the comb, retreating into the warm darkness of the black wax interior. Dilip's uncle tied off the last of his improvised reinforcements and stepped back from the ledge. Dilip released the weight of the comb from his shoulders and straightened his spine, wincing at the protest of muscles held too long in static tension. Hira remained at the attachment point for a moment longer, his hand resting lightly on the black wax surface, his lips moving in silent prayer. Then, without speaking, without acknowledging what had just occurred, the three men began their descent. They moved slowly, carefully, their bodies heavy with exhaustion and the accumulated venom of hundreds of bee stings. The bamboo ladder, slick with rain, required extra caution. Each rung had to be tested, each handhold verified before weight could be transferred. But they descended steadily, rhythmically, with the patience of men who have learned that haste is the enemy of survival. When they reached the terrace, the women were waiting. Not with questions. There would be time for questions later, around the evening fire, when the honey had been processed and the tools cleaned and the bodies of the hunters treated with herbal salves and gentle hands. Not with congratulations. What was there to congratulate? The men had done what the covenant required, no more, no less. Not with expressions of fear or relief. These emotions were private matters, not to be displayed in the public space of the harvest terrace. The women simply received the men as they had received their fathers and grandfathers and great-grandfathers for 1400 generations. They took the harvesting sickles and the collection baskets and the coiled lengths of nettle cord. They guided the hunters to the flat rocks where generations of their ancestors had rested after the climb. They placed cups of salted butter tea in their swollen, sting-covered hands. And then, in voices so soft that I could barely hear them over the wind, they began to sing. The song was old, older than the Gurung language, older than the Tibetan Buddhist traditions that had shaped the spiritual landscape of these mountains, older perhaps than the Himalayas themselves. Its melody was simple, almost primitive, a descending five-note phrase repeated with subtle variations. Its words, insofar as I could distinguish them, were not words at all but vocables. Pure sound, pure vibration, pure expression of something that predated language and would survive its eventual disappearance. The hunters listened. Their swollen faces, distorted by edema and exhaustion, gradually relaxed. Their breathing slowed. Their hands, still gripping the teacups, ceased their fine tremor. The bees, still circling the terrace in diminishing numbers, gradually dispersed, returning to the colony on the cliff above. And the song continued, weaving its ancient spell of healing and remembrance, connecting this moment to all the moments that had preceded it, this harvest to all the harvests that had come before, this generation to the 1400 generations of hunters and harvesters who had renewed the covenant on this same cliff, under this same sky, in the shadow of these same ancient peaks. Later that evening, after the honey had been processed and stored, after the tools had been cleaned and the ching carefully disassembled and stowed in its protective shelter, after the hunter's stings had been treated with poultices of crushed marigold and turmeric and the prayers of thanks offered to the mountain and the bees and the ancestors, I sat with Dilip on the low stone wall that marked the eastern boundary of his family's property. The storm had passed completely. The sky was clear, black, filled with more stars than I had ever seen, the entire galactic core arching overhead in a river of ancient light. Annapurna South and Hyanchali were invisible, swallowed by the darkness, their presence marked only by the absence of stars along their silhouettes. Dilip did not speak for a long time. His face, in the starlight, was calm, almost peaceful, the edema from the day's stings already beginning to subside, the tension of the climb gradually releasing from his young shoulders. "The bees," he said finally, "will remember this." I waited. There was more. I could feel it gathering in the silence between us. Not as individuals. A bee's memory lasts only as long as its life, and a worker in the harvest season lives only a few weeks. But the colony remembers. The collective memory of the hive, the queen's pheromones, the workers' dances, the accumulated experience of tens of thousands of individuals. This persists across generations. This is how the colony knows which cliffs are safe, which flowers are abundant, which humans honor the covenant. He paused, his dark eyes fixed on the invisible massif to the north. Today we added a new memory to that collective store. The bees will remember that when the storm came, the hunters stayed. That when the comb was in danger, human hands reinforced its attachments. That the covenant is not merely a transaction, honey for non-aggression, but something deeper. Something that binds us together, across species, across generations, across the vast gulf that separates the winged from the upright, the stinging from the stingable. He turned to face me directly, and in the starlight, his young face held an expression that I could not fully interpret. Not pride, not sorrow, not hope, but something that contained elements of all three. "This is what my father tried to teach me," he said. "Not how to climb, not how to cut honey, not how to endure stings. Those are just techniques. They can be learned by anyone with sufficient practice and determination. What he tried to teach me was harder. He tried to teach me that the covenant is real. That the bees are not resources to be exploited but partners to be respected. That the honey is not a commodity but a gift, and that every gift carries with it an obligation." He paused, and when he spoke again his voice was so soft that I had to lean close to hear it over the wind. "I am not ready," he said, "but I am learning." There is a word in the Gurung language that has no direct equivalent in English. It is beautiful, which I have previously translated as the place where the ghosts rest. But this translation, like all translations, is a betrayal. Beautiful does not refer to a location. It refers to a relationship. It is the word for the space between the living and the dead, the visible and the invisible, the human and the more than human. It is the word for the cliff where the bees nest, yes, but it is also the word for the moment just before sleep, when the boundaries of the self begin to dissolve. It is the word for the feeling of being watched by something that has no eyes. It is the word for the silence that follows the end of a story that has been told for 40,000 years. Hira Gurung spoke this word only once in my presence. It was the evening after the storm harvest, when the honey had been processed and stored, when the hunter's stings had been treated with poultices of marigold and turmeric, when the cheng had been carefully disassembled and stowed in its protective shelter. We sat on the low stone wall at the eastern edge of his property, watching the last light fade from the Annapurna Massif. His wife had brought us tea, salted butter tea the color of pale caramel, with a thin film of yak fat shimmering on its surface. She had not spoken. She had not needed to. Hira was quiet for a long time. His weathered face, illuminated by the dying light, was impossible to read. It held the stillness of mountains, the patience of glaciers, the deep, unarguable calm of a man who has made peace with forces beyond his control. Then he said, "Beautiful," not as a statement, not as an explanation, as an invocation, as a prayer, as the final word of a story that had been told for 1400 generations and would not be told again. I waited. The silence between us stretched and deepened, becoming its own kind of language. "When I was a boy," he said finally, "my father brought me to this wall. I was younger than Dilip, perhaps 8 years old, perhaps 9. It was autumn, the season after the harvest, when the cliffs are empty and the bees have descended to their winter refuges in the river gorges. We sat here as we are sitting now, and we watched the light leave the mountains." He paused, his dark eyes fixed on the invisible horizon. "My father said to me, 'The bees are not here, but they are not absent. Their absence is a presence. The cliff holds their memory, as it holds the memory of every colony that has nested there since before our ancestors learned to climb. When you stand at the base of beautiful Danda and you do not see the shadow on the rock, you are not seeing emptiness. You are seeing the shape of what is waiting to return." Hira turned to face me, and in the fading light, his eyes held an expression that I had never seen before. Not in him, not in any of the hunters, not in any of the elders who had shared their stories and their silences with me over the weeks of my visit. "I did not understand what he meant," Hira said. "I was a boy. I understood only what I could see and touch and taste. The honey was real. The stings were real. The weight of the comb in my hands, the vibration of the ladder under my feet, the taste of salt butter tea after a long climb, these were real. Absence was not real. Absence was nothing." He paused, and when he spoke again, his voice was so soft that I had to lean close to hear it over the wind. "Now I understand. Now I am old enough to see that absence is not nothing. Absence is the shape of what has been removed. It is the negative space left behind by departure. It is the footprint of the vanished, and it is growing. He gestured toward the cliff, beautiful Danda, the ridge where the ghosts rest, invisible now in the darkness but present in his gesture, present in his memory, present in the ancient weight of his outstretched arm. When I was a boy, he said, there were 12 colonies on that cliff. 12 shadows against the gray granite. 12 black wax cities, each containing 50,000 souls, each connected to the others by threads of scent and vibration and shared genetic inheritance. When my father was a boy, there were 18. When his father was a boy, there were 24. When his father's father was a boy. He stopped. The sentence hung in the air between us, incomplete, impossible to complete. Today, he said, there are 3. The silence that followed this statement was not the silence of shock or grief. It was the silence of recognition, of a truth that had been known at some level for a very long time, finally being spoken aloud. I had read the scientific literature before coming to Nepal. I knew that Apis laboriosa was classified as data deficient by the IUCN Red List, a bureaucratic designation meaning essentially that we do not know enough about the species to determine its conservation status. I knew that the few studies that had been conducted, scattered across decades and national boundaries, suggested population declines in every surveyed region. I knew that climate models predicted the rhododendron forests, the primary nectar source for the Himalayan giants, would lose more than half their current range by the end of this century. But knowing these facts intellectually is not the same as understanding them. Understanding requires translation, not between languages but between epistemologies. It requires converting the abstract language of scientific papers into the concrete language of lived experience. Hira Gurung had been conducting this translation his entire life. The bees are leaving, he said. Not all at once. Not dramatically. They do not abandon their combs in panic, as they do when attacked by predators or destroyed by disease. They simply do not return. A colony that has nested on a particular cliff for 1,000 years, for 10,000 years, for 100,000 years, one spring, it does not reappear. The shadow that has marked the rock since before my ancestors learned to speak does not darken the granite at dawn. The cliff is empty. The absence begins. He paused, his weathered hands wrapped around his teacup, his eyes fixed on something I could not see. We call this Maori Keo Maya, the silence of the bees. It is not a sound. It is the absence of sound. It is the space where the drone of 50,000 ventilation wings used to be. It is the negative of a photograph that was never taken. It is the memory of a vibration that no longer vibrates. He raised his cup to his lips, took a slow, deliberate sip of the cooling tea, and set the cup back down on the stone wall with the same careful precision he brought to every action. The young people do not hear it, he said. They have grown up in a world where the silence is already present. They do not know what they are missing because they have never experienced its opposite. But we, the old ones, the ones who remember, we hear it constantly. It is the background radiation of our existence. It is the bass note of the Anthropocene. He turned to face me, and in the starlight, his eyes were wet. "Beautiful," he said again. "The place where the ghosts rest. But the ghosts are not the bees. The ghosts are us. The hunters, the harvesters, the keepers of the covenant. We are the ones who are becoming ghosts. We are the ones who are fading into the rock. We are the ones who will soon exist only in the negative space of absence." He paused, and when he spoke again, his voice was barely audible above the wind. "The bees will survive. They have survived ice ages and asteroid impacts and the rise and fall of empires we have never heard of. They will survive our warming world, our fragmented forests, our disrupted monsoons. They will retreat higher into the mountains as they have always done when conditions become unfavorable. They will adapt. They will persist. But we will not. The covenant requires both parties. When the last hunter who remembers the old prayers, the old techniques, the old relationship with the bees, when that hunter dies, the covenant dies with him. The bees will continue their ancient labor on cliffs that no human will ever climb. The honey will drip from uncut combs and be consumed by beetles and bacteria. The red stream will flow only into the waiting mouths of the mountain's other children. And the silence will be complete. The extinction of a species is not a moment but a process. It does not occur when the last individual draws its final breath, though that is the moment we mark on calendars and in legal documents. It begins much earlier, decades, centuries, millennia before, when the conditions that enabled the species to flourish begin to deteriorate. It accelerates as populations become fragmented, isolated, unable to exchange the genetic material that maintains evolutionary resilience. It reaches its terminal phase when reproduction falls below mortality, when the old die faster than the young are born, when the accumulated wisdom of millions of years of adaptation begins to leach out of the collective memory of the species. And then, finally, the last individual dies. Alone, most likely. Unobserved. Unremarked. Its passing is not an event but a cessation, the final subtraction in a long series of subtractions that have already, for all practical purposes, rendered the species extinct. This is the silent extinction. It is happening now to thousands of species across the planet, in forests and oceans and mountains that most humans will never visit. It is happening to the Himalayan giant honeybee. And it is happening to the Gurung honey hunters, whose relationship with Apis laboriosa has persisted for 40,000 years and will, within the lifetime of Dileep's children, almost certainly cease to exist. The drivers of this dual extinction are multiple and mutually reinforcing. The first driver is climate change. The Himalayas are warming at approximately twice the global average rate. Since 1950, the mean annual temperature in the Nepalese Himalayas has increased by 1.3 degrees Celsius. By 2050, it is projected to increase by an additional 1.5 to 2.0 degrees. These numbers seem small. A flicker on the thermometer, a rounding error in the vast calculus of planetary climate. But for organisms adapted to the narrowest of thermal niches, they are catastrophic. The rhododendron forests are responding. Rhododendron arboreum, the primary nectar source for Apis laboriosa in the spring, has begun its slow migration upslope. Its lower limit, once at approximately 1,500 meters, has retreated to 1,800 meters. Its upper limit has advanced from 3,000 to 3,300 meters. The entire species is climbing the mountains, following the retreating isotherms as surely as the glaciers are retreating up their valleys. The bees are following. Their spring colonies, once established at elevations between 1,500 and 2,000 meters, are now found above 1,800 meters. Their summer colonies, once concentrated between 2,500 and 3,000 meters, now extend to 3,300 meters and beyond. Each decade, the bees climb approximately 50 meters higher. Each decade, the habitable zone, the vertical band between the lower limit of the rhododendrons and the upper limit of the bees' flight capacity, narrows. This is the second driver, oxygen. The flight muscles of Apis laboriosa are among the most efficient in the insect world, capable of generating sufficient lift to carry the bee's massive body through air that is 40% less dense than at sea level. But even this extraordinary adaptation has limits. At approximately 3,800 meters, the air becomes too thin for sustained flight. A bee can still launch itself from a cliff edge and glide to lower elevations, but it cannot commute, cannot travel repeatedly between colony and forage site, carrying nectar and pollen back to its waiting sisters. The rhododendrons are already blooming at 3,500 meters. Within decades, they will reach 3,800 meters. Within a century, they will surpass it. The bees will be faced with an impossible choice: remain at altitudes where they can fly but find no food, or follow the flowers into altitudes where food is abundant but flight is impossible. Neither choice leads to survival. The third driver is the honey hunters themselves, or rather their absence. The covenant between humans and bees is not merely symbolic. It has tangible ecological consequences. The gurung do not harvest randomly. They select specific colonies, specific combs, specific quantities of honey, guided by generations of accumulated knowledge about what constitutes a sustainable harvest. They leave the brood combs untouched. They leave sufficient honey stores to sustain the colony through winter. They do not harvest from colonies that appear stressed or diseased. They do not harvest during poor flowering years, when the bees' own stores are already depleted. This selective pressure has shaped the evolution of Apis laboriosa for 40,000 years. Colonies that nested on inaccessible cliffs, beyond the reach of human harvesters, were left alone, but they also lost access to the benefits of the covenant, including the hunter's removal of old, disease-prone comb and their occasional reinforcement of weakened attachments. Colonies that nested on accessible cliffs and tolerated human presence received these benefits, but they also paid the cost of reduced honey stores. Over millennia, this dynamic produced a meta-population of colonies distributed across the landscape, each adapted to its specific combination of human interaction and environmental conditions. It was a stable system, resilient to perturbation, capable of absorbing shocks and recovering from losses. Now the hunters are aging and their children are leaving. The selective pressure is relaxing. The meta-population is fragmenting. Colonies that have been managed for millennia are being abandoned to natural processes that they are no longer equipped to handle. The covenant is dissolving, and with it, the ecological relationship that has sustained both species for 400 centuries. The fourth driver is us. Not the Gurung, they are victims of this extinction, not perpetrators. Not the Nepalese government, which has done little to protect either the bees or the hunters' traditional rights, but which lacks the resources and political will to address a crisis of this scale. Not even the international conservation organizations, which have focused their Himalayan efforts on charismatic megafauna, snow leopards, red pandas, Bengal tigers, while ignoring the insects that pollinate the forests and the indigenous communities that have stewarded those insects for millennia. No. Thus, I refer to as larger, more diffuse, more difficult to locate and even more difficult to hold accountable. It is the global economic system that incentivizes a teenager in Gandrik to abandon his father's Cheng and seek work in a Dubai construction site. It is the consumer culture that makes a Kathmandu hotel job seem more desirable than a life of risk and tradition and deep, intimate connection to the non-human world. It is the educational system that teaches young Gurung that their grandparents' knowledge is superstition, that science has superseded the covenant, that the only path to success is the path away from the mountains. This is the silent extinction. It is not caused by any single actor or force. It is the cumulative product of millions of individual decisions, each rational within its own context, each contributing to an outcome that no one intended and no one can prevent. The bees are leaving. The hunters are aging. The covenant is dissolving. And the silence is growing. The final morning of my stay in Gandrik dawned clear and cold. I had planned to leave at first light, hiking down to the roadhead at Birathanti and catching a local bus to Pokhara, then a tourist bus to Kathmandu, then a series of airplanes that would return me to my own world of climate-controlled offices and fluorescent lighting and the peculiar, persistent anxiety of modern urban existence. My notebooks were full. My recording devices were loaded with interviews and ambient soundscapes. My camera contained more images of bees and cliffs and weathered Gurung faces than I would ever be able to organize, let alone publish. I was ready to leave. I was also, in ways I could not articulate and did not fully understand, desperate to stay. Here a Gurung met me at the edge of the village as I was adjusting the straps of my pack. He was alone. No Dilip, no uncle, no silent wife with her unnameable tea. He carried a small bamboo cylinder, sealed with twisted cloth, no larger than his forearm. "This is for you," he said. He did not explain. He did not need to. I recognized the cylinder immediately. It was the same one he had shown me on my first evening in his home, the relic containing the honey of his grandfather's grandfather. The honey that had been harvested 14 generations ago, before the British came to India, before the Mughals, before the Mallas, before any of the empires and kingdoms and principalities that had risen and fallen in the shadow of these peaks. I started to protest. The words died in my throat. "You will not consume it," Hera said. "That is not your path, but you will carry it. You will take it to your country, your laboratory, your people with their microscopes and their computers and their questions that have no answers. You will tell them about the bees. You will tell them about the hunters. You will tell them about the covenant." He paused, his dark eyes holding mine with an intensity that I had never seen in him before. "And when the last colony on beautiful Danda has fallen silent, and the last hunter who remembers the old prayers has joined his ancestors in the rock, and the covenant is nothing more than a memory preserved in bamboo cylinders and aging notebooks and the fading recollections of old men who outlived their own tradition. When all of this has passed, you will still have this honey. You will still have this evidence that we existed, that the bees existed, that the relationship between our species was once real and reciprocal and sacred." He pressed the cylinder into my hands. Its weight was negligible. Its significance was incalculable. "This is the last light," he said. "This is the final shadow. This is the silence, preserved in wax and venom and the accumulated memory of 1400 generations. Take it. Carry it. Remember us." I could not speak. My throat was constricted with a grief that I had not earned and did not deserve. The grief of a witness, not a participant. The grief of someone who arrives at the end of a story and discovers that he has missed everything that mattered. Hira seemed to understand. He placed his weathered hand on my shoulder, briefly, lightly, the same hand that had gripped the Cheng through 40 meters of vertical ascent, that had reinforced the attachments of a black wax cone during a Himalayan storm, that had held the bodies of his father and grandfather and great-grandfather as they passed into the silence. "Go," he said. "Tell the story. That is your covenant now." He turned and walked back toward the village, his silhouette dissolving into the morning mist as if he were already becoming the ghost he had spoken of the previous evening. I watched until I could no longer distinguish his form from the gray stone of the terrace wall, the gray stone of the houses, the gray stone of the mountain that had claimed his ancestors and would, in time, claim him as well. Then I hitched my pack onto my shoulders and began the long walk down. The bus ride to Pokhara took 7 hours. The road from Gandrik to Birathanti is not a road in the Western sense. It is a track of compressed gravel and exposed bedrock, carved into the hillside by generations of foot traffic and recently widened to accommodate the occasional jeep or tractor. I walked it in solitude, my thoughts as fragmented and dispersed as the morning clouds that clung to the lower slopes of Annapurna south. At Birathanti, I found a microbus, a dented Toyota Hiace with 14 passengers wedged into 12 seats and 3 more on the roof, that delivered me to Pokhara's tourist district shortly after noon. I checked into a hotel, showered the trail dust from my skin, and sat on the balcony overlooking Phua Lake, watching paragliders descend from Sarankit in slow, graceful spirals. The bamboo cylinder sat on the table beside me. I had not opened it. I would not open it. Its contents were not intended for my consumption. not in any sense of that word. My role was not to taste the honey but to transmit it, to carry it across oceans and continents and epistemologies, to deliver it to the future that Hira Gurung had entrusted to my care. This is the burden of the witness. This is the weight of the story. This is the covenant transferred across species and generations and the vast, unbridgeable gulf that separates those who climb from those who watch. The flight to Kathmandu was brief, 25 minutes in a Bombardier Dash 8, climbing over the Himalayan foothills and then descending into the brown haze of the Kathmandu Valley. I watched the peaks recede through the scratched plexiglass of the airplane window. Manaslu, Ganesh Himal, Langtang Lirung, their names as beautiful and untranslatable as the word beautiful. The peaks did not look back. They never do. In Kathmandu, I spent 3 days packing and repacking my specimens, my recordings, my notebooks filled with observations and interviews and the tentative beginnings of this story. I visited the Natural History Museum at Tribhuvan University, where a young entomologist named Dr. Sharma examined my photographs of the black wax comb and confirmed what I had already suspected. The micropillar arrays I had documented on the comb surface had never been described in the scientific literature. They were a new discovery, a previously unknown adaptation of an already extraordinary species. "We should publish this," Dr. Sharma said, her eyes bright with the peculiar excitement of a scientist who has stumbled upon something genuinely novel. "With your photographs and my lab's SEM facility, we could have a paper ready for submission within 6 months." I nodded, made appropriate noises of agreement and enthusiasm, and carefully avoided the question that hovered unspoken between us. What is the point? What is the point of documenting the adaptive morphology of a species that is already in terminal decline? What is the point of publishing a paper that will be read by a few dozen specialists, cited a few times, and then consigned to the vast digital archive of scientific literature that no one ever reads? What is the point of adding another brick to the cathedral of knowledge when the cathedral itself is crumbling? The answer, I realized, is the same answer Hira Gurung had given me when he pressed the bamboo cylinder into my hands. Tell the story. That is your covenant now. We tell the story because the story is all we have. We tell the story because the bees cannot tell it themselves. We tell the story because the hunters are aging and the children are leaving and the covenant is dissolving, and if we do not tell it, it will disappear into the same silence that has already claimed 90% of the colonies that once darkened the cliffs of beautiful Danda. We tell the story because that is what witnesses do. This is the story I have carried across oceans and continents and the vast, unbridgeable gulf between witness and participant. It is not a complete story. I have omitted much. The names of the hunters who are not Hira and Dilip, the specific locations of the cliffs that are not beautiful Danda, the prayers and rituals and songs that were shared with me in confidence and are not mine to transmit. I have simplified complex ecological relationships, glossed over scientific controversies, compressed decades of ethnographic observation into a few thousand words. I have failed in countless ways to do justice to the richness and depth of the relationship between the Himalayan giant honeybee and the Gurung honey hunters. But I have told the story. That is my covenant. That is all I can do. Now the story must find its own way in the world. It must encounter readers who have never heard of Apis laboriosa, never imagined a black wax comb suspended from a Himalayan cliff, never considered the possibility that the relationship between humans and insects could be anything other than exploitation or extermination. It must persuade them that this relationship matters, not as a curiosity, not as a relic, not as a data point in the vast catalog of human cultural diversity, but as a model of what might be possible if we learn to see the non-human world not as a resource to be managed but as a partner to be respected. This is a difficult persuasion. Our culture teaches us that nature is a machine, that animals are automatons, that insects are so alien to our experience that we cannot meaningfully relate to them at all. It teaches us that the only legitimate relationships are those mediated by markets and contracts and the cold calculus of cost-benefit analysis. It teaches us that the past is obsolete, that tradition is superstition, that the only path forward is the path of technological acceleration and economic growth. The Gurung teach something else. They teach that relationship is not a transaction but a covenant. They teach that the non-human world is not a machine but a community, populated by beings with their own intentions and perspectives and forms of intelligence. They teach that the past is not obsolete but present, compressed into the bodies of the old and the songs of the women and the honey stored in bamboo cylinders sealed with twisted cloth. They teach that the covenant between humans and bees is not a metaphor. It is real. It is reciprocal. It is sacred. And it is ending. The final colony on Beautiful Danda is still there. I checked before I left. Hira took me to the base of the cliff on my last evening in Gandrik, and we stood together in the fading light, watching the shadow darken against the gray granite. The bees were active, their ventilation drone carrying clearly through the thin, cold air. The soldiers performed their shimmering display, that stroboscopic dance of flexing abdomens that the Gurung call Chayakeo Nritya. The queen, somewhere in the warm darkness of the black wax interior, continued her endless labor of egg-laying. The colony is healthy, Hira said. Strong. The queen is young. She will lay for another 2 years, perhaps 3. Her daughters will swarm and found new colonies on other cliffs. The lineage will continue. He paused, his weathered face turned toward the shadow on the rock. But not here. This cliff is too warm now, too exposed. The rhododendrons are blooming earlier each spring, and the bees emerge from their winter clusters to find the flowers already faded. The monsoon arrives later and departs sooner, and the summer nectar flow is interrupted by weeks of desiccating drought. The colony survives, but it does not thrive. It persists, but it does not expand. It is a remnant, a memory, a ghost of what it once was. He turned to face me, and in the dying light, his eyes held an expression that I will carry with me for the rest of my life. This is the final lesson of the bees, he said. They teach us that survival is not the same as flourishing. They teach us that persistence is not the same as resilience. They teach us that a species can continue to exist, can continue to build combs and rear brood and produce honey, long after it has ceased to be what it was meant to be. They teach us that extinction is not a moment but a process, and that the process can last for generations before the final silence falls. He paused, and when he spoke again, his voice was barely audible above the wind. They teach us that we are not separate from this process. We are part of it. We are not the witnesses of extinction. We are its agents. Every decision we make, to stay or to leave, to climb or to watch, to honor the covenant or to let it dissolve, shapes the trajectory of our own extinction as surely as it shapes the extinction of the bees. He placed his hand on my shoulder, briefly, lightly. "Go," he said. "Tell the story. That is your covenant now. This is the story. I have told it as faithfully as I can, given the limitations of my perspective and the constraints of my medium. I have not exaggerated the intelligence of the bees or the wisdom of the hunters. I have not sentimentalized the covenant or romanticized the danger. I have tried, as Hira Gurung tried with me, to translate a way of knowing that is not my own into a language that my readers can understand. The translation is imperfect. It is always imperfect. The word beautiful does not mean the place where the ghosts rest, and the phrase Maori Keo Maya does not mean the silence of the bees. These are approximations, placeholders, the best I can do with the impoverished vocabulary of my native tongue. But perhaps the imperfection is the point. Perhaps the gap between what I have written and what I witnessed is the space where the covenant resides. Perhaps the story is not the destination but the journey, not the answer but the question, not the honey but the search for it. Perhaps the silence is not an ending but a beginning. The last time I saw Hira Gurung, he was standing at the edge of the village, his silhouette dissolving into the morning mist. The bamboo cylinder containing his grandfather's honey was in my pack, its weight negligible, its significance incalculable. The bees on beautiful Danda were beginning their daily foraging, their dark bodies streaming out of the black wax comb and into the thin, cold air. I did not look back. I did not need to. The image was already burned into my memory. An old man, a stone wall, a mountain that had witnessed the rise and fall of empires and would, in time, witness the dissolution of the covenant that had bound his people to the bees for 40,000 years. This is the silent extinction. It is not a catastrophe but a process, not an event but a transition, not a death but a fading. It is the shadow on the cliff, growing fainter with each passing year. It is the absence of sound where there used to be a drone of 50,000 ventilation wings. It is the negative space left behind by departure, the footprint of the vanished, the memory of a vibration that no longer vibrates. It is beautiful. It is the place where the ghosts rest, and we are the ghosts. As we conclude our story here, I am very grateful for your listening and support up to this point. I would appreciate it if you would subscribe and give me a small like. See you in my next interesting and educational videos. Stay with science. Good night.